Okay, so we are about to start set one of the paper code 65 to 1, and this is the subset one of the second set. So let's start with the first question, which is MCQ of 1 mark. It says that the sum of all elements of a 3 by 3 scalar matrix is 9. So what is a scalar matrix? So scalar matrix is a square matrix which has, because its order is 3, so its the scalar matrix is uh, square as well as the diagonal matrix in which all the diagonal elements are equal. So let's say this is matrix 3 by 3, and it has elements a11, a12, a13. So this is a21, a22, a23, and this is a31, a32, and a33. So this is square matrix of order 3. Now, a scalar matrix is the matrix in which all the diagonal elements, that is, all these diagonal elements, these are the diagonal elements, all these are diagonal elements are equal. So let's say these are diagonal elements values be k, and all other elements are 0. So this is a scalar matrix in which all the diagonal of order 3. So it is a diagonal matrix in which all the principal diagonal elements are equal and all other elements are 0. So it's given that the sum of all elements of a 3 by 3 scalar matrix is 9. So all the elements are, this is k plus 0 plus 0 plus 0 plus k plus 0 plus 0 plus 0 plus k is equal to 9. And if we add them, this is 3k is equal to 9, which gives me the value of k as 3. So this k is 3. Okay, so k is 3, but we have to find the product of all its elements. So because we have to find the product, so that will mean 3 into 0 into 0 into 3 into 0 into 0 into 0 into 3, and that would be equal to 0. So 0 is the correct answer for this. And to solve this question, we should know what is a scalar matrix. So scalar matrix is a diagonal matrix in which all the principal diagonal elements are equal and all other elements are 0. So because this is a order 3 matrix, so this is 3 by 3. Let's move on to the next one. Okay, for question number 2, uh, there's a function that's defined from set of all r plus is the set of all non-negative real numbers, and it's defined from this set to set which contains the real numbers from -5 to infinity. So, and the function is this 9x squared plus 6x minus 5. We have to check whether it's 1, 1 onto bijective, either 1, 1 or onto. So let's try to understand the question first. This is the domain, and domain consists of all positive real number, that is non-negative real numbers, and the codomain, that is the value of y, this is the value of x, and this is our output. It contains, this is the set from -5 is included to infinity. Okay, and this function is defined as f of x is equal to 9x squared plus 6x minus 5. We have to check whether it's 1, 1 or onto. Okay, so 1, 1 or onto, what we will do, we will consider two elements that belongs to the domain, so that x1 and x2 belongs to the set of all negative non-negative real numbers, and let their respective images be fx1 and fx2. Now let's assume that these both two images are same, and we know that the function is 1 1 as well when for every x there is a unique y, for every element x there is a unique image. So if we are considering that these two images are same, then these two should not be different. These two should also be the same. That is, for only one element, there is a unique image. So let's put in the value of x11. According to this function, the value of f of x1 is, this is 9 x1 square plus 6 x1 minus 5 is equal to 9 x2 square plus 6 x2 minus 5. Okay, so negative 5 and negative 5 plus cancel. And let me arrange or try to get this solved. So 9x square, this is minus 9x2 square plus 6x1 minus 6x2 is equal to 0. And for these, the common is 9x1 square minus x2 square, and for these common is 6. So x1 minus x2 is equal to 0. Then a square minus b square, which gives me 9a, let it be, plus b into a minus b plus 6 into x1 minus x2 is equal to 0. Now for these two terms, our common factors are 3 x1 minus x2, and now we are left with, this is 3 x1 plus x2 plus 2 is equal to, okay, so which gives me, actually this should, okay, now out of these two factors, either 3x1 minus x2 is equal to 0, or 3 into x1 plus x2 plus 2 is equal to 0. But this cannot be 0 because x1 and x2, these are both the belong to the set of non-negative real numbers. That means this is positive, this is positive, this is positive, this is positive. So this cannot be 0. And now this, we are left with this, which gives me x1 minus x2 is equal to 0. So therefore, x1 is equal to x2. That means if two images are equal for two different values of x, then these two are also not different. These two are also the same value. These two are also equal, which gives me that the given function f is 1, 1. Now let's check this function for onto, if it's onto or not. And for onto, our function is, so how do we say that a function is onto? And to define function, or a function is onto, when for every y that belongs to the set, there exists x that belongs to the domain, so that f of x is equal to y. So for onto our function, it goes from all set of positive real numbers to minus 5 to infinity. Okay, now, and f of x, our function is defined as, this is 9x squared plus 6x minus 5. So when will this function be onto? So this function is onto. So we can say that the function is onto when, for every, for every y that belongs to minus 5 to infinity, that is the codomain, there exists x, and x should be, and it should be such that f of x should be equal to y. Okay, so let's try to check whether it's onto or not. Let's try to check that for every value that is in codomain, there should be an x. Okay, now our function is f of x is equal to 9x squared minus 6x plus 5. This is our function. 9x squared, sorry, this is 9x squared plus 6x, and this is negative 5. And f of x means this is y, so y is equal to, so this is a quadratic equation. Let's try to get it into uh, some known form, a minus b or a plus b the whole square. So I'm going to take 9 common, so we are left with x squared, and this is 6 by 9x minus 5 by 9. So this is 3 to the 6, 3. So finally we have y is equal to 9. This is x squared plus 2 by 3x minus 5 by 9. Yeah. Okay, 9. So we are going to change this into a plus b the whole square. So x squared plus half of this. So half of this is 1 by 3. So I'm going to add, so this is 2 by 3x minus 5 by 9. So I'm going to add 1 by 3 the whole square and subtract it in this. So y is 9 y. So this is now a square plus b square plus 2 into a. So this is a square 2 into a into b plus this is b square, and we are left with this is negative 5 by 9 and minus 5 by 9. Okay, now which gives me 9. This is now a square plus b square plus 2ab. So this is a plus b the whole square, and this is minus 6 by 9, which is 2 by 3. Okay, so now finally I can write y as, so y is equal to x plus 3 the whole square, and okay, so this is 9 into x plus 1 by 3 the whole square minus 2 by 3. And let's multiply all these with 9, so which gives me 9 into x plus 1 by 3 the whole square and 9 into minus 2 by 3, so which is 6. So this is minus 6, and how this is okay. So finally we have y, and I can write it as, so this is 9, and this can be written as 3 square in x plus 1 by 3 the whole square. So this is 3 into x plus 1 by 3 the whole square minus 6. And finally, I have got it reduced to, so let's multiply this. So 3 into 3x, so 3x plus 1 the whole square minus 6. And this is y. And let's take 6 to the left hand side. So this is y plus 6 is equal to 3x plus 1 the whole square. We are going to get the value of x. So 3x plus 1 is equal to under root y plus 6. This is plus minus, which gives me 3x. So 3x is equal to, this is minus 1 plus minus root of y plus 6. And I can write x is equal to minus 1 plus minus root of y plus 6 by 3. So finally, I've got the value of y. Now, uh, we are going to prove that when x belongs to all non-negative real numbers, okay, now here we have x that belongs to all non-negative real numbers, and here y, we are given that y belongs to minus 5 to infinity. That means y is greater than equal to negative 5. So y is greater than equal to negative 5. Okay, now y is greater than equal to negative 5. I'm going to add 6 on both the sides. So which gives me y plus 6 is greater than equal to negative 5 plus 6. And this is now equal to y plus 6 is greater than equal to 1. Let's square root on both the sides. So square it on both the sides will give me, this is root of y plus 6 is greater than equal to the root of 1, which is 1. And let me add negative 1 on both the sides. So this is negative 1 plus y of 6 is greater than equal to root of 1 is 1, and negative 1, which will give me 0. And I'm going to divide this with 3 as well. So this is now equal to negative 1 plus root of y plus 6 upon 3 is greater than equal to, this is 0. So 0 by 3 is 0. So this is 0. So that, and this value is our x. X is greater than equal to 0. So that means for every y. So if for every y that was greater than equal to minus 5, we have x which is greater than equal to 0, and this x is greater than equal to 0 means that this belongs to all non-negative real numbers. So for every y that belongs to minus 5 to infinity, there exists x that belongs to, so we can say that for every y that belongs to minus 5 to infinity, there exists x that belongs to non-negative real numbers such that f of x is equal to 9x squared plus 6x minus 5. So our function is on, and as function is 1 1 and on to. So when the function is 1 1 and on to, that means that the function is bijective. So this function is bijective. So the function which is 1 1 and on to is bijective, and our option should be option C. Let's move on to the next question. Okay, for question number 3, we have to find the value of the determinant, and sorry, we have to find this determinant is equal to k ABC, then what is the value of k? So let's try to evaluate it along the row R1. So this is the row, first row R1. So this should be minus a, and the first element minus a, and removing the row and the column for negative a, we are left with the determinant BC, sorry, minus BC and B negative C. So this is plus and this is negative, so this is negative B. And removing the row and the column for the second element, we are left with the determinant AC, A negative C, and after that it's plus C. So one is plus, negative, and this plus. So C, removing the row and the column for the third element, it's A and negative B and A and B. So this is, and this value is equal to K into ABC. Okay, so let's try to evaluate this. So this is negative A, B into C, negative B into negative C is BC minus the product of these, which is BC minus B. And this one, this is A into negative C, which is negative AC plus C. And this is AB, and plus AB is equal to K into ABC. Okay, my BC minus BC is 0, so this term is 0 minus B into minus 2 times AC plus C into 2 times AB is equal to KABC. Okay, so this is now 2ABC plus 2ABC is equal to K into ABC, which is 4 times ABC into K into ABC. This gets cancelled, and the value of K is 4. So D is the correct answer. Moving on to the fourth one. Question number 4, we have to find the number of points of discontinuity of the function, and the function is given as. Okay, so let's try to rephrase this function. So this function is equal to, and here for the first value of the function, for x is less than equal to minus 3, it's modulus of x plus 3. And we know that for the modulus function, when x is less than equal to 0, the value is negative x. So it has it's less than equal to minus 3, so this is negative x. So this one can be written as negative x plus 3 when x is less than equal to negative 3. Okay, for the second value of the function, that is minus 2x, this is when x is greater than minus 3 but less than 3, and 6x plus 2 when x is greater than or equal to 3. Now This function is defined on the points minus 3 and 3. So let's say this is negative 3 and we have these intervals. So for less than negative 3 or equal to negative 3, the value of the function is negative x plus 3. And between negative 3 and 3, it's negative 2x. And for greater than equal to 3, it's 6x plus 2. So let's try to check the continuity of these uh, function of let's try to check the continuity of this function on points negative 3 and 3. So first one is at x is equal to negative 3. So at x is equal to negative 3, when the value of the function is negative 3, it's negative of x plus 2. So this is negative, and x is negative 3 plus 3, which gives me 6. Let's find out the left hand limit. So left hand limit is equal to limit. This is x tends to negative 3 negative, and for less than 3, the value of the function is negative x plus 1. So this is limit x tends to negative 3 minus, which is negative x plus 1. Okay. So the left hand limit means this is the function, and let's assume here that x is equal to a small value h less than negative 3, and when x tends to 0, h tends to 0. So this is as x tends to 0, h tends to 0. So I can write this limit now in terms of h, that is when limit h tends to 0. This is negative, and x is negative 3 negative h plus 3, which gives me limit h tends to 0. So this is 3 plus h plus 3, and taking the limit, putting h is equal to 3, which gives me the value 6. Let's find out the right hand limit. So right hand limit is x tends to 3 plus, okay, this is negative 3. So when the value of the function, when a value of the x is greater than negative 3, the function is negative 2, and this is limit x tends to minus e plus negative 2x, and I can write it as x tends to negative 3 plus negative 2 into x. Now x here, let x be a small value h greater than minus 3. So here as x tends to negative 3, h tends to 0. So this limit can be written as limit h tends to 0. And this is now negative 2x is minus 3 plus h, which gives me limit h tends to 0. This is 6 plus, or this is 6 negative 2h, and when I take the limit, taking the limit for h is equal to 0, this value is equal to 6. So this function is continuous as value of the function as negative 3 is equal to left hand limit is equal to right hand limit is equal to 6. So x is equal to negative 3 is a point of continuity. Now let's check the continuity of this function at x is equal to 3. So when x is equal to 3, function is defined at x is equal to 3, function is defined as 6x plus 2. So this is 6x plus 2, which gives me 6 into 3 plus 2 is equal to 20. Now let's find out the left hand limit. So left hand limit is limit x tends to 3 negative f of x, and for value of x less than 3, x when x is less than 3, the function is negative 2x. So this is limit x tends to 3, this is 2x, okay, sorry, this is negative 2x. And now let's assume that let x is equal to a small value h less in 3, and here as x tends to 3, h tends to 0. So this function is now defined for limit h tends to 0, which is minus 2x is 3 minus h, which gives me limit h tends to 0. This is negative 6 plus 2x, and taking the limit, putting h is equal to 0 here gives me negative 6. Okay, obviously this function is not continuous because the left hand limit is not equal to the value of the function, but let's find out. Let me show you how to find out the right hand limit for the function. So when the value of the x is greater than 3, the value of the function is defined as 6x plus 2. So this is 6x plus 2, and let's say let x is equal to a small value greater than 3, and as x tends to 3, h tends to 0. Okay, now this limit has been changed to h. So limit h tends to 0 gives me 6 into 3 plus h plus 2, which gives us limit h tends to 0. So this is 6 3, that is 18 plus 6h plus 2. And if I put h is equal to 0 here, which gives me 20. Now the value of the function at 3 is not equal to left-hand limit, and left-hand limit is not equal to the right-hand limit. So value of the function is equal to right-hand limit, but left-hand limit is not equal to right-hand limit. So x is equal to 3 is a point of discontinuity. So it's asked in the question how many points of discontinuity are there. So there is one point, that is x is equal to this. So function is discontinuous at x is equal to 3. Moving on to question number 5. For question number 5, we have to find where the function is strictly decreasing, or choose out of these four options. So we are going to use the first order derivative test, and the given function is f of x is equal to x cubed minus 3x squared plus 12x minus 18. So let's find out the first order derivative. Now the differentiation of x cubed is 3x squared, and this is would be 6x plus 12. Okay, and let's take a 3 common. So this is x squared minus 2x plus 4. And now let's try to get this into some sort of squares. So this is x squared. And how do we do that? So let's multiply this with the half, which gives me 1. So I'm going to add and subtract the square of 1 to this, so which gives me 3 into, so this is x squared a square plus b square minus 2b ab, which gives me a minus b the whole square, and 4 minus 1 is 3. Now this value 3 is positive. X minus 1 the whole square will always be positive. 3 is positive, so that means this is greater than 0. So that means f dash x function is greater than 0. So that means the function is for all values of r which belongs to, with all values of x which belongs to r, f is strictly increasing on r. So B is the correct option. Moving on to question number 6. Okay, for question number 6, we have to evaluate this definite integral for the value 0 to pi by 2. And the function, the integrand into differential element is dx on 1 plus sine x, 1 plus sine x into cos x. Let's consider this integrand as, let's say this is I. So it has to be evaluated for the limits 0 to pi by 2. This is sin x minus cos x upon 1 plus sin x into cos x at the differential element dx. Now we are going to use, let this be equation 1, and we are going to use the property here. The property is 0 to a, and it says that 0 to a for f of x into dx, it can be written as 0 to a f of a minus x into dx. Okay, so let's use this property on this, which gives me I is equal to integration of 0 to pi by 2, and this is sine of pi by 2 minus x minus cos of pi by 2 minus x upon 1 plus sine of pi by 2 minus x into cos of pi by 2 minus x into dx. Okay, now this can be written as I is equal to 0 to pi by 2. Now sine pi by 2 minus x is cos x, and cos pi by 2 minus x is sine x. And this is now 1 plus sine pi by 2 minus x is cos x. So the denominator remains same, into sine x into dx. Let this be equation 2. So we are going to add 1 and 2. So 1 and 2 gives 1. Adding I plus I is 2i, and this is 0 plus pi by 2. This was sine x minus cos x. This is sine x minus cos x plus cos x minus sine x, and denominator is same. So this is 1 plus sine x upon 1 plus sine x into cos x is same. So this is 1. I can write it as 1 plus sine x into cos x. This gets cancelled. Now 2i is equal to 0 to pi by 2, which is 0 upon 1 plus sine x into cos x, which is equal to 0. So 2i is equal to 0, which gives me I is equal to 0. And we have our option as B. So B is the correct option here. So this is option B. Moving on to question number 7. For question number 7, the differential equation dy by dx is equal to f of x or y will not be homogeneous differential equation if f of x, if the function in terms of x and y is out of these. Now, out of these, all these functions, uh, this one, the option A, and how do we check that the given function is a homogeneous, given differential equation is a homogeneous differential equation or not? So let's consider this like f, this is f of x of y, and if this is like if I substitute x with lambda x and y with lambda y, so if you see, this is now changed to, because there is no way to cancel lambda x, so that means this cannot be a homogeneous uh, differential equation, because in all other functions, if we substitute y with lambda y and lambda x with lambda x, we still get y by x, which is the original function. Similarly here, if we substitute x with lambda x and y with lambda y, here x with lambda x and y with lambda y, so for this common is lambda square, and here it's lambda square into x and y. So we are still getting the original differential equation. And here we will also get the original differential equation by substituting x with lambda x and y with lambda y. So this is still the original differential equation except the first one. So it's will not be a homogeneous equation, will be the option A. Okay, for question number 8, we have to choose which of the following statement is always true. And these are all the dot products of vectors A and B. And we know that the dot product of vector A and B is given as the magnitude of A into magnitude of B into cos theta. Now, the maximum value of this cos theta, now this value will exceed this when this is greater than the this side, and the maximum value of cos theta is 1. So that means its maximum value can be A dot B and magnitude of A into magnitude of B. So this is the maximum value of A dot B. And so that means Either this can be equal to this or less than this. So C is the correct option for this one. Okay, for question number 9, we have to find the coordinates of the foot of the perpendicular drawn from the point 0, 1, comma 2 on the x-axis. And let's say this is the x-axis, and let this be the point P, which is 0, 1, comma 2. Let this be the point P, and let's draw a perpendicular from this point P, and let Q be the foot of the perpendicular. So because this foot is on the x-axis, so its coordinates are in 0, 0. Now we have to find the coordinates of the foot of the perpendicular, that is, we have to find the value of A. Now the vector equation of PQ. So PQ vector would be A minus 0. So this is AI cap minus J cap minus 2K cap. This is the vector equation of PQ. Now the vector equation of x-axis. So vector equation of x-axis for the point Q, it has only one coordinate, that is AI cap, and all else are 0. This is the vector equation of x cap, and because PQ vectors is perpendicular to XX vector, that is the x-axis, so that means the dot product of A1 into A2 plus B1 into B2 plus C1 into C2 should be equal to 0. So A1 is A, A2 is also A, plus B1 is -1, B2 is 0, C1 is -2, C2 is 0, which gives me A square is equal to 0. So A square is equal to 0, and that should give me A is equal to 0. So A is 0, so that means the coordinates of the foot of the perpendicular is D, 0, comma 0, comma Z. Okay, this one is the easiest one. The common region determined by all the constants of a linear programming problem, and we know that for a linear programming problem, the common region determined by all the constraints of a linear programming problem is called the feasible region. And let me show you what is the feasible region. So let's say these are the coordinate x's, and we have drawn some graphs of the constraints, inequality graphs of the constraints, and this goes something like this. And let's say this is the common region. This is the common region, and for all these, so this is called the feasible region because the solution for all these inequalities lies in this space. So this is the option D, feasible region. Looking for question number 11, it's given that E is an event of a sample space, as sample space means it contains all the events, and we have to find the probability of S by E. So we know that probability of S by E, A by E, is probability of S intersection E divided by the probability of E. Now, the common between the sample space and the event is the event. So this is probability of E by probability of E, which gives me the answer as C. Moving on to question number 12. Okay, for question number 12, it's given that the matrix is defined as A is equal to Aij element with 3 by 3 matrix where Aij is I minus 3j. So this matrix A, now this is of the order 3, so that means it has elements A11, A12, A13, A21, A22, A23, and A31, A32, and A33. So this is of the order 3 by 3. Let's try to get all these elements. The first one is the A11, and this is the formula. So Aij is equal to I, this is I minus 3j, and for A11 this is 1 minus 3, which is equal to -2. So this is -2. Similarly, A12 is equal to 1 minus 3 to the is 6, which is equal to -5. So this is -5. and let's get A13. So A13 is 1 minus 3 caesar is 9, which is negative 8. So similarly, let's get A21, A22, and A23. So A21 is, this is 2 minus 3, which is equal to negative 1. So this is negative 1. A22 is 2 minus 3 to the 6, which is negative 4. This is 2 minus 3 6 is 9, which is negative 7. So 1, negative 4, and negative sign. And this matrix is coming as negative 2, 5, negative 8, negative 1, negative 4, negative 7. Okay, now for A31. So this is A31, A31. This A31 will be equal to, this is 3 minus 3, which is equal to 0. So this is 0. And A32 is 3 minus 3 to the is 6, which is negative 3. So this is negative 3. And A33, so A33, which is 3 minus 9, which is equal to negative 6. So we have our matrix as minus 2. So this is minus 2, negative 5, negative 8, and minus 1, minus 4, minus 7, 0, negative 3, and f. So is A11 greater than 0? So A11 is less than 0, which is true. So A12 plus A21, A12 plus A21. So if we add this, this is minus 6, which is true. So A13 is greater than A31. A13 is here, and A31 is here. So this is greater than 0, which is false. So which of the following is false? C is false, and A31 is 0, which is correct. So our option is option C for this one. Moving on to question number 13. Okay, for question number 13, we have to find the derivative of tan inverse x squared with respect to x. So let's say this function is y is tan inverse x squared, and now we are going to differentiate this with respect to x. So differentiation of y is dy by dx, and differentiation of tan inverse x. And we know that the differentiation of tan inverse x is 1 upon 1 plus x squared, which gives me 1 upon 1 plus, instead of x squared, we have x raised power 4, and differentiation of x squared using the chain rule is 2x. So this is 2x upon 1 plus x raised power 4, which is option B. Moving on to question number 14. Okay, for question number 14, we have to find the degree of the differential equation. And this differential equation is not, this is not a differential equation, because y double dash means it's the second order derivative, the whole square, plus y dash means first order derivative dy by dx, the whole cube, is equal to x into sine of y dash, which is dy by dx. So because we have this trigonometric function where the function is itself a differential equation, so this is not a differential equation and its degree is not defined. Moving on to question number 15. Okay, for question number 15, we have to find the unit vector perpendicular to both these vectors. So let that unit vector be ai cap plus bj cap plus ck cap. Now this unit vector is perpendicular to I cap plus k cap. So that means the dot product, that is ai cap plus bj cap plus ck cap, its dot product with I cap plus k cap should be equal to 0, which gives me a into 1 plus b into 0 plus c into 1 is equal to 0. So that gives me a plus c is equal to 0. That is the equation 1. Now this vector, this unit vector, is also perpendicular to one more vector, that is ai cap plus bj cap plus ck cap is also perpendicular to I cap minus k cap. So that means now the dot product ai cap plus bj cap plus ck caps, dot product with I cap minus k cap is equal to 0. and that gives me a into 1 plus b into 0 plus c into 1 is equal to 0. So now c into 1, this is actually negative. So plus this is c into negative 1 is equal to 0. So that gives me a minus c is equal to 0. And if I solve these two equations, which gives me a is equal to 0 and c is equal to 0. So our unit vector, this reduces to, this is 0 I cap plus b j cap plus c k, 0 into k cap is equal to 0. So our unit vector is finally reduced to bj cap is equal to 0. Now the magnitude, because this is a unit vector, so this is a unit vector, so its magnitude is equal to 1. So magnitude of this is equal to 1. So magnitude of this is equal to 1, which gives me b is equal to 1. So that means our vector is j cap. So this is, so j cap means b is the correct option. Moving on to question number 16. Okay, for question number 16, we have to find the direction ratios of a vector parallel to this line. Now we know that a vector parallel to a line, let's say this is x minus x1 by a, is equal to y minus y1 by b is equal to z minus z1 by c. If this is the Cartesian equation of a line, so vector which is parallel to this line has the direction ratios a, b, and c. Because this is the vector ai cap plus bj cap plus ck cap that is parallel to this line. So that means we are going to get this in the standard form. So our equation is, this is x minus 1 by 2. So we are going to write this in the standard form. That is, try to get this in the standard form x minus x1. This is the standard form, and this is now, this is correct. So y, I can write it as y upon negative 1, and 2z I can take 2 common here, so this is z plus 1 by 2 by 6, so this is 3. So finally our Cartesian equation of the line is x minus 1 by 2 y upon negative 1 and z plus 1 by 2 by 3. And as I told you that these are the direction ratios of the vector which is parallel to this line. So direction ratios are 2, negative 1, and 3. So 2, negative 1, and 3, that is D is the correct answer. Moving on to question number 17. Okay, for question number 17, it's given f of x is equal to cos x minus sin x is equal to 0. And f of x the whole square is equal to f of kx, and what is the value of k? So let's find out f of x the whole square. So f of x the whole square should be the product of f of x into f of x. So this is cos x negative sine x into 0, and this is sine x into cos x 0, 0, 0, 1. You have to find the product of this with fx into f of x, so cos of sine x 0, and this is sine x into cos x 0, this is 0, 0, and 1. Okay, let's multiply this, and I'm going to find this product, expand this. Okay, we have to not expand this, we have to multiply this. So first row and first column, so this is cos x into cos x, which is cos square x, negative x, negative sine x into sine x is negative sine square x, and 0 into 0 is 0. So this is our first element. Next is negative cos x into sine x plus, and this is once again negative sine x into cos x and 0. So third element is cos x into 0 is 0, sine x into 0 is 0, and 0 into 1 is 0. So this is 0. Now the second row with all the columns. So sine x into cos x is sine x cos x, and cos x into sine x is cos x, sin x. Yes, and then 0 into 0 is 0. So negative sin x into negative sin x is sin square x. Cos x into cos x is cos square x, and 0 into 0 is 0. So once again, 0 into 0, 0 into 0, and 1 into 1 is 1. Okay, now the third row, 0 into cos x is 0, 0 into sin x is 0, and 1 into 0 is 0. So this element is 0. Now 0 into minus sin x is 0, 0 into cos x is 0, and 1 into 0 is 0. So this is also 0. And 0 into 0 is 0, 0 into 0, and 1 into 1 is 1. So this is f of x, the whole square. And let me write it as this is now cos square x minus sin square x. This is minus 2 times sin x into cos x, 0 third element, and this is 2 times sin x into cos x. This is cos square x minus sin square x 1 and 0, 0, 1. Okay, this is f of x the whole square, and it has to be equated with f of kx. So let's find out f of kx. So f of kx is simply all the elements multiplied with k. So let's just verify our f of, okay. So cos square x minus sin square x is cos 2x. So I can write it as cos of 2x. 2 sin x into cos x is sin 2x. So this is negative sin 2x 0. This is sin 2x cos square minus sin x. Cos square x minus sin square x is cos of 2x 1, 0, 0, and 1. So this is f of x the whole square. Okay, so cos 2x, sin 2x, cos 2x. Okay, now let's equate this to f of x. Now this was equal to f of x. Now f of x is just multiply all the elements with, sorry, f of kx. This is f of kx. Just multiply all the elements with k, which would give me cos of, multiply all x with k. So this is cos of kx and minus sine k of x minus sine k of x is equal to 0. And this is sine of kx cos of kx and 0. And this is 0, 0, 1. So this is f of kx. So at last I have equated these, and we have to find the value of k. So let's equate the corresponding elements and let the value of k. So I can equate any of these. So let me just equate negative sine x to negative kx. So because these two matrices are equal, so let's say, let me equate this element. Negative of sine 2x is equal to negative of sine kx. Negative negative gets cancelled, and we get 2x is equal to kx. X's gets cancelled, and finally our value for k is 2. So value of k is 2. So B is the correct option. Moving on to question number 18. Okay, for question number 18, it's given that a line makes an angle of 30 degree with the positive direction of y-axis. And let's say these are our axes x, y, and z. And we know that the angle made by a line with the x-axis is known as alpha. And let this be the line. Okay, this makes an angle. This is x-axis, this is y, and this is z. So this line makes angle of 30 degree with the x-axis. So this is the angle that it makes with positive direction of x-axis, where the y-axis is 120 degree. Now this angle is known as 30 degree, and this angle is known as beta. The z-axis angle is known as gamma. So we have to find this, and we know that Cos of all these angles, that is cos square alpha plus cos square beta plus cos square gamma is equal to 1. So let's put in the respective values. So cos square alpha is 30 degree, beta is 120 degree plus cos square gamma is equal to 1. And we have to find gamma here. Okay, now cos 30 is root 3 by 2. So this is root 3 by 2 the whole square cos 180 degree. So this is cos 120 degree can be written as cos 180 minus 60. So this is cos 180 minus 60 and a 180 means no change. This is cos and we are in the second quadrant. And in the second quadrant for cos 180 minus 60, cos is negative. So this is negative cos 60, which is negative half. So this can be written as negative half the whole square. So this is negative half the whole square plus cos square gamma is equal to 1. So root 3 by 2 the whole square is 3 by 4. This is 1 by 4 plus cos square gamma is equal to 1. So 3 by 4 plus 1 by 4 is 4 by 4, which is 1. So cos square gamma is equal to 0, which means cos gamma is equal to 0. And we know that the angle for which cos is 0 is cos 90. So that means gamma is equal to 90 degrees. So A is the correct option. For question number 19 and 20, these are the lesson and the reason based questions, and two statements are given. So for any symmetric matrix A, B, uh, dash AB is Q symmetric matrix, and the reason is that A square matrix P is Q symmetric if P dash is equal to negative. So we have to check this. And for question number 19, so let's check the assertion first. And it's given that A is a symmetric matrix. So that means if A is a symmetric matrix, for any symmetric matrix A, if A is a symmetric matrix, that means A transpose is equal to A. And if symmetric A is a symmetric matrix, then this is also skew symmetric, and we know that skew symmetric matrix is one in which the transpose is equal to the negative of the matrix. So let's check this. Let's try to get this and see if it's equal to negative of this. So this is B transpose AB. So B transpose AB. So let's consider this as one unit. So this is B transpose AB. So let's find out the transpose of this. So this is B transpose AB, the whole transpose. And we know that AB, the whole transpose, is equal to B transpose A transpose. So B transpose A transpose. So that means I can write it as, let's consider this as one unit. So this is AB, the whole transpose into B transpose. Okay, and AB, the whole transpose, I can write it as using this formula once again. So this is B transpose A transpose into B transpose. So now B transpose A transpose is symmetric. So A transpose is equal to A and B transpose is B transpose. Okay. Okay, sorry, this is the transpose of, if you use this formula on this, so this is B transpose and A transpose. So transpose of transpose is the matrix. So this is B. Okay, now we have B transpose into AB, and so that means the transpose of this matrix is B transpose AB. It's not equal to negative. So this is a skew matrix which is false. So this assertion is false. And a square matrix P is a skew symmetric matrix if P transpose is equal to P transpose. The reason for this is also the reason for this was that it's the definition of the square matrix P skews matrix. So B, if P transpose is equal to P, which is true, So reason assertion false and the reason is true. The assertion is false and the reason is true means that we are going to check. So assertion is true and reason is false. Assertion is true and reason R is false. So that means our option is option out of the four options. Assertion A is false, reason R is true, which is D. So D is the correct option for this. Assertion R is false and reason R is true. D is the correct option. Moving on to question number 20. Okay, for question number 20, which is also assertion and the reason based, should be the easiest one. Okay, assertion is for two non-zero vectors, the dot product is commutative, that is A dot B is equal to B dot A, which is true. We have read that in the properties of the dot product of the vectors, and this is the cross product. So A cross B is not equal to B cross A. It's not commutative, so it's false. So C is the correct option for this. Let's move on to question number 21. For question number 21, part A, this is section B, and we have defined the value of the given tan inverse of minus 1 by root 3. So let's try to find these values one by one. So for the first one is tan inverse minus 1 by root 3. Let's say this is equal to y. So I can write it as tan y is equal to negative of 1 by root 3. And we know that the angle for which the value of tan is 1 by root 3 is pi by 6. So I can write it as tan of, sorry, pi by 6, which is 30 degrees. So this is tan of pi by 6. And now this is negative of tan x is equal to tan of a negative x. So this can be written as this is tan y and this is now equal to, which gives me y is equal to minus pi by 6. So this is equal to minus pi by 6. So the value of tan inverse this is minus pi by 6. Moving on to cot inverse. So finding the value of cot inverse 1 by root 3. So let's say y is equal to cot inverse 1 by root 3, and I can write it as cot y is equal to 1 by root 3. Now the angle for which the value of cot is 1 by root 3 is cot 60, which is cot pi by 3 is cot 60, which gives me y is equal to pi by 3. So this is pi by 3. Okay, now let's find out the value of this tan inverse. So let's say y is equal to tan inverse sine of minus pi by 2. I can write it as y is equal to tan inverse. Now sine of minus x is equal to negative sine x. So this becomes a negative sine of pi by 2. And the angle sine pi by 2 is sine 90, which is 1. So this is 1. And now this can be written as tan y is equal to negative 1. And the angle for which uh, the value of tan is 1 is pi by 4. So I can write it as negative tan pi by 4. And this is now tan y is equal to negative of tan x is equal to tan x. So this is tan pi by 4, which gives me y is equal to negative pi by 4. So this is negative pi by 4. Okay, let's try to simplify this now. Now the LCM of 6, 3, and 4 is 12. So this is minus 2 pi plus 4 pi minus 3 pi. Okay, so this is now equal to uh, minus 2 pi minus 3 pi is minus 5 pi plus 4 pi is negative pi by 12. So negative pi by 12 is the answer for this. Moving on to question number, that is the second part of this same question 21. Okay, for part B of the question number 21, we have to find the domain of the function. And the function is given as f of x is equal to sine inverse of x square minus 4. Now we know that the domain for the function, now this function, the domain of the function means that we have to find the value of x. Now for this function, sine inverse function, this value is, that is the sine inverse of x square minus 4. This is the domain and it's always between minus 1 and 1. So that means, and x square minus 4 is always greater than equal to minus 1 but less than equal to 1. So let's try to find the value of x from here. So if I have to find the value of x, let me add 4 on for every term here. So this gives me 3 is greater than equal to, this gets cancelled, is greater than equal to 5. Okay, let's consider this part first, this part of inequality first, which says x square is less than equal to 5. So that means x square minus 5 is less than equal to 0. And I can write it as a square minus b square is less than equal to 0. So that means x minus 5, x minus root 5 into x plus root 5 is less than equal to 0. And for these less than equal to 0, one of them should be positive and one should be negative. So I'm going to consider this. Let me consider this as less than 0, less than equal to 0. X minus root 5 is less than equal to 0, which gives me x is less than equal to root 5. Okay, and the other one, it should be positive. So x plus root 5 should be greater than equal to 0, which gives me x is greater than equal to negative root 5. So x is less than equal to root 5 but greater than equal to root 5. And if we plot this on the number line, let's say this is negative 5 and this is negative root 3. So this is our solution set here. Okay, for this one. So greater than, less than equal to root 5 but greater than equal to minus root 5. Now let's consider the second part of this inequality, which says x square is greater than equal to root 3. So which gives me x square minus t is greater than equal to 0. And now this is a square minus b square, which is a minus b into a plus b is less than equal to 0. Actually, this is greater than equal to 3. So this is greater than equal to 3, greater than equal to 0, greater than equal to 0, greater than equal to 0. And for this, x minus root 3 is greater than equal to 0, which gives me x is greater than root or equal to root 3. And this gives me that x should be less than equal to negative root 3. Okay. And if I plot this on the number line, these values of x, so root 3 should be somewhere here and the negative root 3 should be somewhere here. And the value, okay, negative root 3. And this is 0. So this is for this, x is greater than equal to root 3 means this region. And x is less than equal to negative root 3 means this region. And the common for minus 5, so minus root 5 to root 5, and the common region for these and these values of x is this region, that is this region and this region is negative 5 to negative root 3, and this is root 3 to root 5. So value of x, that is the domain, belongs to negative root 5 to negative root 3, and root 3 to root 5, and let's make union of these. So this is the domain, that is negative root 5 to negative root 3 union root 3 to root 5. And I just made one mistake here, that is it should be the closed interval. The values are also included. This is the closed interval. Okay, this is root 3 to root 5. Okay, now range for every, we know that the range for sine inverse x, where the values of x are -1 to 1, its range is negative pi by 2 to pi by 2. So our range is negative pi by 2 to pi by 2. Moving on to question number 22. For question number 22, part A, we have the function f of f is equal to modulus of tau n to x, and we have to find the value of f dash x at x is equal to pi by 3. So our function is f of x is equal to modulus of 10 to x, and we can write this function as, now this value is 10 to x when x is greater than 0, and negative of 10 to x when x is less than 0. So we have to find the differentiation of these two cases at x is equal to pi by 3, and let's consider the first case when this 10 to x. Let's consider our function as f is equal to 10 to x. So the function is f of x is equal to 10 to x when x is greater than 0, and differentiation, this is differentiation of 10 is, this is secant square 2x, and differentiation of 2x is 2, so this is 2 secant square 2x. Now we have to find its differentiation at pi by 3, to simply replace the value of x with pi by 3. So this is 2 into secant square 2 into pi by 3. So this is 2 secant square 2 pi by 3. Now let's evaluate secant square 2 pi by 3. So secant square 2 pi by 3 is 2 into 180 by 3, which is equal to 2 secant square 120. And I can write secant square 120 as 180 minus 60. So we are in the second quadrant, and in second quadrant secant is negative. So pi 180 means that secant remains secant. So this is secant square, this is 2 into negative. So this is secant square 180 minus 60. So all sine, this is secant 60, or rather, let me write it as 120. So 120 divided by 90 gives 91, that is 90. So I can write it as 90 into 1 plus 30. Okay, now let's try to evaluate this. So 90 means change, secant becomes cosecant, and we are in the second quadrant where this is negative. So this is negative cosecant square 30. And now cosecant 30, sine 30 is reciprocal, which is negative 2 square, so which is equal to 8. So the answer for this is 8. And similarly, we have to find the value when f dash x. So when f of x is equal to negative of 10 to x, so its differentiation is f dash is equal to negative secant square 2x into 2, and this is equal to negative 2 secant square 2x. We have to find its value at pi by 3. So everything else is same, just the negative sign. So negative 2 secant square 2 into pi by 3, which gives me 2 secant square 2 pi by 3, and that should be equal to negative 8, because we have already evaluated this, which is 8. So multiply this with negative sign, so negative 8. So this function has the value 8 and negative 8 at x is equal to pi by 3. Let's move on to part B of question number 22. Okay, for part B of question number 22. So this is question number 22's part B, and it's given that y is equal to cosecant of cot inverse x. Now we know this identity where 1 plus cot square theta is equal to cosecant square theta, which gives me cosecant square theta is equal to cosecant theta. So if I have to write this in terms of cosecant theta, so cosecant theta is equal to 1 plus cot square theta. So I'm going to use this identity here. So for cosecant theta, I can write it's under root 1 plus cot square, and theta is this. So this is cot inverse x. Now cot of cot inverse x is x square. So this is 1 plus this is x cot inverse, and because it's x square, so this is x square because it's x square, so it's x square, and y is equal to, so we have used identity here, 1 plus cot square theta is equal to cosecant square theta, which gives me cosecant theta is equal to 1 plus cot square theta. Now cot into cos inverse x is x, and we have to square that, so it's uh, x square. Now let's differentiate this, so dy by dx is equal to, this is a differentiation of 1 under root of 1 plus x square is 2 under root 1 plus x square, and differentiation of x square is 2x. This gets cancelled. So dy by dx, let's rearrange this. And if I take this to the left hand side, this is 1 plus x square into dy by dx is equal to x. So now finally it's 1 plus x square into under root of 1 plus x square into dy by dx is equal to negative 0. So under root of 1 plus x square into dy by dx, negative x is equal to 0. This is what it was asked to prove. Moving on to question number 23. For question number 23, it's given that if m and m denote the local maximum and local minimum values of the function f of x is equal to x plus 1 by x, we have to find the values of local maxima. We have to find the difference of the local maximum, that is m, and local minimum, that is negative m. So let's find out the local maximum, the minimum value first. So our function is f of x is equal to x plus 1 by x, and differentiating this with respect to x. So differentiation of x is 1, and differentiation of 1 plus x is negative 1 upon x square. Okay, so let's find out for local maxima or minima. And we know that for the critical values, that is for the local maxima or minima, f dash x is equal to 0. So this is 1 minus 1 by x squared, which is equal to 0, which gives me negative 1 by x squared is equal to negative 1, and x squared is equal to 1. So x is equal to plus minus 1. So our values for x, so x is equal to negative 1 or 1. And let's find out the second order derivative using the second order derivative test. So f dash x would be the differentiation of this. So differentiation of 1 is 0, and differentiation of this minus 1 by x square is, this is a negative, so negative 2 into x raised power minus 3, which gives me 2 upon x cube. So this is the second order derivative. Let's find out the value of negative 1 for second order derivative, which is 2 upon minus 1 cube, which is equal to negative 2, which is less than 0. So that means x is equal to minus 1 is a point of maxima. So x is equal to 9 is 1 is a point of maxima, and a point of maxima is denoted by M, capital M. So this is M. Now for the second order derivative, for f is equal to 1, it's 2 upon 1 cube, which is 2, which is greater than 0. So that means x is equal to 1 is a point of minima. So x is equal to 1 is equal to small m is a point of minima, and we have to find the difference. That is, okay, now this is not, so this is a point of minima. So this is a point of minima, and we have to find the local maxima and the minima. So m and small n capital M. So at this, the value of the function at -1 is, this is -1 plus 1 upon -1, which is -1 minus 1 is equal to -2. So this is the local maximum value, which is equal to m. So our m is -2. And let's find out the value of the function at f is equal to 1, which will give us the local minimum value. So 1 plus 1 by 1 plus 1 upon 1 in the function gives us 2. So this is the local minimum value. And we have to find the difference of the local maximum and the local minimum value. So -2 minus 2 minus 2 is -4. So -4 is the difference between the local maximum and the local minimum. Moving on to next question number, and that is question number 24. Number 24, we have to find the integral of e raised power 4x minus 1 upon e raised power 4 plus x. So let's consider this as integral I. So I is equal to integration of e raised power 4x minus 1 upon e raised power 4x plus 1 into dx. Now I can write e raised power 4x. I can write this as e raised power 2x into e raised power 2x -1 upon e raised power 2x into e raised power 2x plus 1 into dx. Okay, now let me just rearrange them so I can write this. Let me take this down 1. So this is e raised power minus 2x -1 upon e raised power 2x upon e raised power minus 2x plus 1 into dx. And why I am doing this is to get this in some standard form so that I can integrate it using one of the methods of the integration. Now, if I take LCM, so this is e raised power 2x minus e raised power minus 2x upon e raised power minus 2x. And for this, it's e raised power 2x plus e raised power -2x upon e raised power -2x. So this gets cancelled into dx. Then this is now equal to e raised power 2x minus e raised power -2x upon e raised power 2x plus e raised power -2x into dx. Okay, now let's make the substitution. So I'm going to substitute e raised power 2x plus e raised power -2x is equal to t. And differentiation of this is e raised power 2x into 2, and differentiation of this is once again e raised power 2x into differentiation of -2x is -2 into, and we are differentiating with this with respect to t. So this is dt by dx is equal to 1. So finally we have e raised power 2x -2 into e raised power -2x into dt is equal to dx. And here 2 is common, so e raised power 2x negative e raised power -2x into dt is equal to t. And finally I can write it as e raised power this into, this should be, we have differentiated x with respect to t, so this should be actually dx by dt is equal to 1. So which becomes dx is equal to dt, dx is equal to dt, and dx is equal to dt half. So that means I can replace this value with half is out and it's dt, and this is t. We know that integration of 1 by t is log of t plus c, and finally our integration for this is half log of e raised power 2x minus e raised power negative 2x plus c. So this is our integration, half log of e raised power 2x plus e raised power minus 2x plus c. Let's move on to question number 25. Okay, for question number 25, we have to show that the function is strictly increasing in its domain. So our function is f of x is equal to e raised power x minus e raised power negative x plus x minus tan inverse x. Okay, let's differentiate it first. So differentiation is e raised power x, differentiation is e raised power x negative, e raised power negative x is differentiation is e raised power negative x multiplied by differentiation of x negative x, which is 1. Differentiation of x is 1. Differentiation of tan inverse x is 1 plus x squared. Okay, which finally gives me the differentiation as e raised power x minus minus, this is e raised power negative x plus 1 minus 1 upon 1 plus x squared. Okay, and finally I can write this differentiation as e raised power x plus 1 upon e raised power x plus 1, and the next one is, okay, so let's me try to simplify this one. So if I take LCM for these two terms, so which gives me 1 plus x squared, and this is 1 plus x squared minus 1. So finally the differentiation is f dash x is equal to e raised power x 1 upon e raised power x plus x square upon 1 plus x square. So this is an exponential function which is always greater than 0. This is always greater than 0. This x square is greater than 0. 1 plus x square is greater than 0. So that means overall this f dash x is greater than 0 for all x that belongs to the real number. And we know that according to the first order derivative test, if the differentiation is greater than 0, so that means this function is strictly increasing in its domain. So finally, I can write that f is strictly increasing over its domain in R. So f is function is strictly increasing over its domain R. So this function is strictly increasing over domain R. So this is strictly increasing function for all real numbers. Moving on to question number 26. Okay, for question number 26, part A, we have to, this section comprises of short answer questions of 3 marks each. And our functions are x is equal to e raised power cos 3t, y is equal to e raised power sin 3t, and we have to prove this. So this is the parametric functions are in the parametric form. So for first function, because both these functions are defined in terms of t, so we are going to differentiate this with respect to t. So differentiating this with respect to t, we get, so differentiation of x with respect to t is dx by dt, and differentiation of e raised power x is e raised power cos 3t, and differentiation of cos is negative sine 3t, and differentiation of 3t is 3. Okay, now y is equal to e raised power sine 3t, and let's differentiate this with respect to t. So differentiating this with respect to t, we get, so differentiating with respect to t, we get dy by dt is equal to e raised power sine 3t. Differentiation of sine is cos 3t, and differentiation of cos 3t is 3. Okay, so we have got the differentiation. Now we have to find dy by dx. So dy by dx can be written as dy by dt divided by dx by dt. So dy by dt is 3 cos 3t into e raised power sine of 3t divided by, this is negative 3 sine 3t into e raised power cos of 3t. So this gets cancelled, and cos 3t. is, so this is cos of 3t, sorry, this is e raised power. This is e raised power cos of 3t and e raised power sine of 3t. So e raised power cos of 3t is x. Actually, I have jumbled it. So dy by dt, so this is dy by dt, this is e raised power sine of 3t into cos of 3t into 3 divided by, this is negative e raised power cos of 3t into sine of 3t into 3, 3 and 3 gets cancelled. Now e raised power sine 3t is y. So this is replaced with y, and this is, so let me put negative up. So this is equal to negative y, and e raised power cos 3t is x. Now this is cos of 3t upon sine of 3t. Okay, now we know that if x is equal to e raised power y, then I can write it as this is equal to, if x is equal to e raised power y. So how do we write that in terms of log? So x is equal to e raised power y, it becomes y is equal to log x. So we are going to use this formula on this. So similarly, this becomes cos 3t is equal to log x. So instead of cos 3t, I can write log x, so minus y log x upon x. Now sine 3t. So this sine 3t, this becomes, so y is equal to e sine 3t. So sine 3t becomes log y. So this is log y. So we have differentiated this. So dy by dx is equal to minus y by x log x upon log y, which is equal to our RHS. Moving on to the second part of the same question. For same question, that is for question number 26, part B, we have to show that differentiation of modulus of x is equal to x upon modulus of x when x is not equal to 0. So that is question number 26, part B. Now we know that this modulus function is the value of, this is x when x is greater than equal to 0, and it's negative x when x is less than 0. So let's, and we have to show that in both the cases, this LHS is equal to RHS. So let's consider the first case when x is greater than equal to 0 and the value is x. So differentiation of modulus of x. Now x is, when x is greater than 0, x is positive. So this is differentiation of x, which is equal to 1. This is LHS. And let's find out RHS. So RHS is x upon modulus x, and modulus x is x. So this is x by x is equal to 1. So that means LHS is equal to RHS. That is, differentiation of modulus x is equal to x upon modulus x when x is greater than equal to 0. And let's consider when x is less than 0. So our LHS is differentiation of modulus of x. Now x is negative x, so which gives me negative 1, and RHS is x upon negative x. So this is x upon negative x, which is equal to negative 1. So that means differentiation of modulus of x is equal to x upon modulus of x when x is less than 0 is equal to negative 1. In both these cases, LHS is equal to RHS. So we have just proved that differentiation of modulus x is equal to x upon modulus of x when x is not equal to 0. So x is not equal to 0 means we have to take this off. When x is, so this is x is greater than 0, and this is x is less than 0. Moving on to the next question, which is question number 27, part A. For question number 27, part A, we have to evaluate the definite integral. So, our definite integral, let's consider this as I, which is has to be written from -2 to 2 under root 2 minus x upon 2 plus x into dx. And let's rationalize it first. So rationalizing means multiplying the numerator and denominator with the conjugate of the denominator. So its conjugate is 2 minus x, which gives us -2 to 2. This is under root 2 minus x the whole square upon this is now a square minus b square. And finally, our integral is I is equal to -2 to 2. This is under root 2 minus x the whole square upon under root. This is 2 square minus x square. So this gets cancelled, and this is -2 to 2, 2 minus x the whole square upon under root 2 square minus x square into dx. So this has all these has the differential element dx. Okay, so this is actually not square. Okay, now let me separate these terms. So -2 to 2. So this is 2 upon under root of 2 square minus x square minus into dx, integration of -2 to 2, which can be written as x on under root of 2 square minus x square into dx. Okay, 2 can be taken out for this. So this is I is equal to 2 is out, -2 to 2. And this is integration of root of 2 square minus x square into dx. Minus this is -2 to 2 x upon under root of 2 square minus x square into dx. Okay, now let's consider this function. Let's consider this function as I1 and the other one as I2. So if I consider I1, so this is I1 is integration of dx upon under root. This is 2 square minus x square into dx. Now this function, our function is f of x, that is 1 upon root of 2 square minus x square. Okay, now f of negative x is equal to 1 upon under root of 2 square. So this is 2 square and negative x square, which still gives me f of negative x is equal to 1 upon 2 square minus x square. So it still gives me f of x. So that means this function is even. And when the function is even, the integration of 0 raised power a or 0 raised power uh, that is when the function is even. So when the function is even, so function the integral 0 to a f of x in the integral of f of x 0 to a, it can be written as 2 into integration of this can be written as 2 into integration of 0 to a 0 to a f of x into dx, and this property is -a to a. So if the definite integral -a to a f of x is even, which indeed this is, so this can be written as 2 into 0 to a f of x into dx. So that means I can write this function that is -2 to 2, because this function is even, so I can write it as 2 into integration of 0 to a. So this is -2 to 2, and I can write this as 0 to a f of x, which is dx into root of 2 square minus x square into dx. Okay, so this function now becomes I1 is equal to 2 into, and this is the formula. We know that the formula of for the differentiation of, sorry, the integration of, we know that the integration of under root a square minus x square is equal to sine inverse x by a. So using this formula on this, we get, so this is sine inverse x by a, which is Okay, so we have got I1. So this is sine inverse x by a. And let's get, so this value becomes 2 into, so let's replace the value of I1, which is 2 into sine inverse x by 2. And it has to be weighted for the limits minus 2 to 2. So minus 2 to 2 are the limits. Okay, and I2. So let's check our function I2. This is I2. And if I check this function, this is odd. So f of x is x upon root of 2 square minus x square. And if I put it this way, if I evaluate this for negative x, this is negative x upon root of 2 square minus x square, which is my negative of x. So that means this f of x is odd. And when f of x is odd, negative a to a into f of x should be equal to 0. This is the property. So this is I2. So I2 becomes equal to 0. So this is negative 0. So we are only left with our integral is, we have only, so 2 into 2 is 4. So this is 4 sine inverse x by 2. And now the limits are not to negative a to a. These are actually 0 to 2. This is actually now 0 to 2. So this is 0 to 2. We have used the property here. So I is equal to 4. This is sine inverse 2 by 2 minus sine inverse 0 by 2. So I is equal to 4. This is 1. So sine inverse 1, angle for which the value of sine is 1 is pi by 2. This is sine 0. And the angle for which the sine 0 is 0. Okay, so now this is 4 into pi by 2, which becomes 2 pi. So 2 pi is the answer for this. And we have solved this using the properties of the definite integral. So let's move on to part B of the same question, that is question number 27, part B. Okay, for question number 27th, part B, we have to find the definite integral of this. And for this, let's say this is our integral I. And then let's get this converted into substandard form. So we are going to make the substitution log x. So log x is equal to t, and differentiating this with respect to t, we get, so differentiation of this will be dx. So differentiation of log x is 1 by x, and x differentiation with respect to t is dx by dt. Dt is differentiation with respect to x. So with respect to t is 1. So we have dx by x is equal to dt. So let's make the substitution here. So this is dx, and this is x, and this is dt. So I is equal to dt, and this is the integration. So this is x into dx is dt log x, which is t square. So this is t square minus 3t minus 4. Okay, let's also get this converted into some standard form, and I'm going to make this um, using the completing the square. For this, I'm going to take the coefficient of t, multiply it with the half, so that would be 3 by 2. So let's add and subtract square of 3 by 2. Okay, so this is t square minus 3t, and this makes the formula. So this is a minus b the whole square. Now negative 4 and negative 3 by 2 the whole square is negative, this is 4, and 9, 4, 16. So this is 25 by 4. And I can write this as t minus 3 by 2 the whole square minus 5 by 2 the whole square. So finally our integral in terms of t is, this is dt 3 minus 3 by 2 the whole square minus 5 by 2 the whole square. Okay, now this is of this integration is of the form 1 upon a square minus x square into dx, and this integration is equal to, this should be equal to 1 by 2a into log of modulus of x minus a upon x plus a plus c. So let's use this formula for this, which gives me I is equal to 1 by 2 into a. A here is 5 by 2, so this is 5 by 2 log of x. In terms of x, we have t minus 3 by 2, so this is t minus 3 by 2 minus a, which is 5 by 2, t minus 3 by 2 plus a, which is 5 by 2 plus c. Okay, so this gets cancelled, and I is equal to 1 by 5 log of, this is 2, this is 2t minus 8 upon 2t, and this is 2 by 2, that's cancelled, plus c. So I is equal to 1 by 5 log of 2 is common, so this is t minus 4, 2 it is t plus 1 plus c, and finally let's resubstitute the value of t, and t was log x. So this is now log x minus 4 upon log x plus 1 plus c. This is the answer. So I is equal to 1 by 5 log. So this is 1 by 5 log of x minus 4 upon log of x plus 1 plus c. Okay, moving on to the next question, that is question number 28. Okay, for question number 28's part A, we have to find the particular solution. That is, we have also to find the value of the constant here for the differential equation given by. So let's write down our differential equation, which is 2xy plus y square minus 2x square into dy by dx is equal to 0. So I'm going to divide each and every term by x square. Let's separate this dy by dx. So divide each and every term by x square. So this is y square by x square minus 2x square divided by x square into dy by dx is equal to 0. So this gets cancelled. Okay. So finally we have 2 into y upon x, and this is y upon x the whole square minus 2 into dy by dx is equal to 0. So this is negative 2 by 2 into dy by dx is equal to negative 2 y by x minus y upon x the whole square. So if we have to eliminate negative 2, so this is dy by dx, and this is y by x plus divided by 2, so this is half into y by x the whole square. So let's make the replacement or the substitution here. Let's replace y by x is equal to v, which gives me y is equal to vx. So this is our equation 1, and differentiating this, the substitution with respect to x, we get, so this is dy by dx, and for this the product rule, so v into differentiation of x plus x into differentiation of v. Okay, this is equation 2, and if we equate these two equations, so these two equations if we equate, which gives me y upon x plus half into y upon x the whole square is equal to v plus x into dv by dx. Let's make a substitution here. This is v, this is half v square is equal to v plus x into dv by dx. This gets cancelled. Okay, now let's rearrange these terms, which gives me, so this is should be equal to 2 into dv upon v square. So let me just write it down what we are left with. So this is half v square is equal to x into dv upon dx. So this can be written as dx upon x is equal to 2 upon v square into dv. So this is our equation, which is dv upon v square is equal to, okay, so rather let me write it as, let me just keep, so this is dv upon v square, and let me just keep half here. So now integrating on both sides, if we take the integration on both sides, so integrating on both sides, so integration of this should be half is out, so this is integration of dx by x is equal to integration of dv by v square. Now integration of x is log x. This is integration of, I can write as v raised power minus 2, and integration should be, this is x raised power n plus 1 upon n plus 1 plus c. So this is now log x by 2 is equal to v raised power negative 1 upon negative 1. Let's replace the value of x, sorry, v. So this is negative 1 upon v plus c, and v was y upon x. So let's replace its value here. So this is y upon x plus c, which makes it negative xy plus c. Okay, now let's find out c. It's given in the question that when y is equal to 2, when x is equal to 1. So y is equal to 2 when x is equal to 1. So let's put in the values here. So x is 1, so this is log 1 by 2 is equal to negative 1 by 2 plus c. Log 1 is 0, so this is 0. Negative half plus c, which gives me c is equal to negative half. Okay, so our differential equation, this one, it finally becomes, so this is log x by 2 is equal to negative x by y plus value of c is half. So if I have to rearrange this, let me just rearrange this to get, so I will keep, so this is negative x y is equal to log x by 2 minus half. So negative x by y is equal to 2. So this is log x minus 1. Okay, now let's cross multiply this. So y into log x minus 1 is equal to negative 2x. So finally y is equal to this is negative 2x upon log x minus 1, and if we have to remove negative, so let's take negative common here, so this is 1 minus log x, and finally our answer is y is equal to 2x upon 1 minus log x. So y is equal to 2x upon 1 minus log x. This is our particular solution for the given differential equation. Moving on to part B of the same question. Okay, for question number 28, part B, we have to find the general solution of the differential equation. So let's try to get into some known form. If I shift or divide each and every term by dy, so this is equal to y into dx by dy is equal to x plus 2y the whole square. So this is dx by dy is equal to x plus 2y the whole square divided by y, and it is xy plus 2y square by y. Okay, so this is dx by dy is equal to x by y plus 2y. And finally, this is dx by dy minus x upon y is equal to 2y, and this is can be compared with px is equal to q. So if we compare these two terms, p is equal to negative 1 by y and q is equal to 2y. And to solve this, let's get the integrating factor. So integrating factor is equal to e raised power p into dy. So this is equal to p is negative 1 by y into dy, and its integration. This is now negative log y, and this can be written as negative log y raised power 1, which is equal to e log 1 by y, and this is equal to 1 by 5. So integrating factor is 1 by y, and solution of such differential equation is given by this is given by x into integrating factor is equal to integration of q into integrating factor into dy plus c. So x into integrating factor. Now integrating factor is 1 by y is equal to integration of q. Q is 2y into integrating factor is 1 by y into dy plus c. So this gets cancelled. So x by y is equal to integration of 2 into dy plus c, which is equal to 2y plus c. And finally, I can write it as x is equal to 2y squared plus cy. So this is the solution. X is equal to 2y squared plus cy. Moving on to the next question, that is question number 29. For question number 29, we have to find the position vectors of vertices of triangle ABC. So, and the position vectors of vertices are given. We have to find all the angles of triangle ABC. So let's say this is triangle ABC with vertices A, B, and C. And let this be vertex A, this be vertex B, and this be vertex C. So vertex A has position vector 2i cap minus j cap plus k cap, and B has position vector I cap minus 3j cap minus 5k cap. And for C, it's 3i cap minus 4j cap minus 4k cap. Now we have to find the angles, that is angle A, B, and C. So for that, let's use the concept of dot product of vectors. And we know that the angle between two vectors, so this is vector AB and this is vector AC. So if you use the dot product for these two vectors, that should be the magnitude of AB into magnitude of AC into cos, and angle between them is A. So that means I can write cos A as the dot product of vector AB, AC divided by their magnitudes. Okay, now how do we find AB? So we have to find vector AB. So vector AB will be the position vector of B minus A. So this is equal to I cap minus 3j cap minus 5k cap minus 2i cap plus j cap. So I'm going to subtract these two vectors, B, position vectors of B and A. So minus 2 plus j minus k cap, which gives me I cap. This is negative I cap, negative 2j cap, and negative 6k cap. So okay, so this is AB vector is negative I cap minus 2j cap minus 6k cap. And now we have to find the AC vector. So AC vector will be C vector minus A vector, and C vector is 3i cap minus 4j cap minus 4k cap minus 2I cap plus j cap minus k cap. So 3 minus 2 is 1. So this is I cap minus 4 minus j cap, and this is minus 5 a cap. Okay, the magnitude of AB. The magnitude of AB would be the AB vector is, this is AB vector, this is AC, so this is negative 1 square plus negative 2 square plus negative 6 square into the magnitude of AC, which is 1 square plus negative 3 square plus negative 5 square. Okay, so finally we have cos AS. So how do we find the dot product? Just find the sum of the product of the scalar components of AB and AC. So minus 1 into 1 plus minus 2 into minus 3 plus minus 6 into minus 5 upon root of this is 1 plus 4 plus 36 into 1 plus 9 plus 25. Okay, this gives me negative 1 plus 6 plus 30 upon this is 36 plus 4 is 40, 41, this is 25, 9 is 34 and 35. So finally we have cos A is equal to 36 minus 1 is 35 under root 41 under root 35, which gives me A is equal to cos inverse of 35 upon under root 41 and under root 35. So this is angle A. So angle A is cos inverse of 35 under root 41 upon under root 35. If you want, you can simplify it further. And if I rationalize this with root 35, so this is root 35 into root 35 upon root 35, which becomes 35 into root 35 upon root 41 by 35. So this is root 35 by root 41. So this is the angle A. Now let's move on to find angle B. So we will use a similar process. Okay, so once again, cos of B will be the dot product of BA and BC divided by their magnitudes. Okay, let's find out BA and BC. Okay, so BA vector is A vector minus B vectors, position A minus position B. So which is okay, 2I minus I is I cap minus J plus 3 would be 2J cap and K plus 5, this is 6K cap. So this is I cap plus 2J plus 6K. So I cap plus 2J plus 6K, and similarly find the dot product, sorry, vector BC, which would be position vector C minus position vector B. Okay, so C vector, say 3I minus I is 2I cap minus 4 minus of minus 3 is negative J cap, negative 4 minus of minus 5 is plus K cap. So this is 2I minus J plus K. 2I cap minus J cap plus K cap, and let's find the magnitude. So magnitude of BA vector would be 1 square is 1, 2 square is 4, 6 square is 36, and this is 2 square is 4, negative 1 square is 1, and 1. So cos B is equal to 1 into 2 plus 2 into negative 1 plus 6 into 1 upon this is root 41 upon this is root 6. Okay, which gives me, and this gets cancelled. This is 6 upon root 41 by root 6, and this can be rationalized further, which gives me 6 root 6 upon root 41 by 6. So B is cos inverse of root 6 by root 41. This is angle B. Moving on to find angle C. Okay, so similarly, cos C would be the dot product of CA vector, CB vector divided by their magnitudes. So let's find out CA. So CA would be A vector minus position vector A minus C. So, so CA is A2 minus 3 is negative I cap minus this is minus 3 J cap, and this is plus 4 K cap. So negative I cap. So 2 minus 3 is negative minus, this should be plus 3, and this is plus K cap. So minus I cap plus 3J plus 5 cap plus 5. This is actually 5. Similarly, let's find out CB vector. So CB vector is position vector B minus C. Position vector B I minus 3 is minus 2I cap minus 3 minus or minus 4 is plus J cap minus 5 minus or minus 4 is minus K cap. So minus 2 cap minus 2 I cap plus J cap minus K cap, and this is, let's find out the dot product divided by the magnitude. So magnitude of CA is 1 plus 9 plus 25. This is 4 plus 1 plus 1. Okay, which gives me cos C is equal to negative 1 into negative 2 plus 3 into 1 plus 5 into negative 1 upon root. This is 34, 35. This is root 6. Okay, this is equal to 2 plus 1, 3. And this is equal to 0. So root 35 by root 6, which is equal to 0. So cos C is equal to 0. That means C is equal to pi by 2. So that means this is a right angle triangle, and we have got all the angles for the triangle ABC. Moving on to question number 30. Before question number 30, it's given a pair of dice is thrown simultaneously, and if x denotes the absolute difference of the numbers appearing on top of dice, then we have to find the probability distribution of x. So for a pair of die, we know that the total outcomes is equal to 36. And what could be the possible differences? So possible differences because the lowest number is the one, smallest is 1, and we have these numbers 1, 2, 3, 4, 5, 6, and it's given that it's the absolute difference. That is, we have to take the absolute value of the difference. So 2 minus 1 or 1 minus 2, it's the same thing. So difference could be with this for the doublets, it's 0 or 1, or 4 minus 2 is 2, 5 minus 3 is 2, and it could be 3, 6 minus 3 is 3. It could be 4, 5 minus 1 is 4, and 6 minus 1 is 5. So these could be the possible outcomes for the differences. And to get the numbers of how many times these differences we will get, so let's write down the outcomes for two dice, and our second die is 1, 2, 3, 4, 5, and 6. So outcomes for these two would be 1 comma 1. This is 2 1, 3 1, and 4 1, and 5 1, 6 1. So this is 1 2, 1 3, 1 4, 1 5, 1 6. And this is 2 2, 2 3, 2 4, 2 5, 2 6, 3 2, 3 3, 3 4, 3 5, and 3 6. This is 4 2, 4 3, 4 4, 4 5, and 4 6. 5 2, 5 3, 5 4, 5 5, 5 6. This is 6 2, 6 3, 6 4, 6 5, and 6 6. Okay, now it's given that x denotes the difference, absolute difference of the numbers appearing on the top of the dice. And so x has the possible outcomes 0, 1, 2, 3, 4, and 5, and we have to find the probability of x. So let's find out the respective probabilities. Okay, now the total outcomes are 36 and 0. 0 appears when the we have doublets. So doublets are 1, 2, 3, 4, 5, and 6. So 6 are the doublets, and this will give us that absolute difference 0. So this is 6 out of 36, which gives me 1 by 6. Now 1, yeah, we will get difference 1 for 1, 2, 2, 1, and 3, 2, 2, 3, 3, 4, 4, 3, 4, 5, 5 4, 6 5, and 5 6. For all these outcomes, the absolute difference would be 1, and these are 1, 2, 3, 4, 5. These are 10. So 10 out of 36. So this is 10 out of 36, which gives 5 by 18. Similarly, the difference 2, you get difference 2 or 1 3, 3 1, 4 2, 2 4, and 5 3, 3 5, 6 4, 4 6. So these are possible 8 outcomes. So this is 8 by 36. So 8 by 36, which gives me it's 4 2s are is 8, 2 by 9. So which is 2 by 9. And for difference 3, we will get absolute difference 3 for 6 3 3 6 or 4 1 1 4. And also for difference 3, it's 6 3 3 6 5 2. So 5 2 and 2 3. So these are total of 6 outcomes. So this is 6 by 36, which gives me 1 by 6. And for difference 4, we will get difference 4 for the outcomes. So difference 4 will be 6 minus 2 and 2 minus 6, or 5 1 and 1 5. So this will give us absolute difference 4, which are 4 outcomes. So 4 by 36, which gives me 1 by 9. So this is 1 by 9, and difference 5. Difference 5 will be 6 1 and 1 6. So this is 6 1 and 1 6. So 6 1 1 6. These are 2 outcomes. So 2 by 36, which gives me 1 by 18. So for absolute difference 0 1 2 3 and 5, these are respective probabilities. This is the probability distribution table for the absolute difference of the numbers appear on top of dice. Let's move on to question number 31. Okay, for question number 31, we have to find the integral of x square into sine inverse x raised power 32 into dx. So let's try to get rid of this by making some substitution, and let's say x raised power 3 by 2 is equal to b, and we are going to differentiate this with respect to t, not with x, but with t we get. So differentiation of x raised power 2 by 2 is n into x raised power n minus 1 into dx by dt. Differentiation of t is 1, so dt goes to this side. This is the differentiation, which gives me x raised power 3 by 2 minus 1 is half into dx is equal to 2 by 3 into dt. So dx is equal to 2 by 3 into x raised power negative half into dt. Now let's make the substitution and let's consider this as I. So I is integration of x raised power sine inverse x raised power 3 by 2 into dt. So dt, this is x square into sine inverse x raised power 3 by 2 is t, and dt is 2 by 3 into x raised power negative half into dt. So 1 by 3 is out. X square into x raised power negative half is x raised power 3 by 2 sine inverse t into dt. X raised power 3 by 2 is t. And I'm going to take the inverse function as the first function, and this is now t. So we are going to use the integration by parts method here to differentiate this. So this is now equal to integration by parts, which gives us, so this is our first function and this is our second function. And we are going to use the product for the two functions to integrate this, and which is first function into integration of second function minus integration of differentiation of first function into integration of second function. The whole has to be integrated again. Okay, let's do the differentiation now. So this is sine inverse t into integration of t is t square by t. Differentiation of sine inverse t is 1 upon under root 1 minus t square into t square by t. That has to be differentiated, integrated once again. So if I multiply this, so which gives me, this is now 1 by 3 sine inverse t into t square. Okay, minus, this is 2 by 3 into 2, if I put 2 out, and finally we have t square upon 1 minus t square, so I'm going to add and subtract 1 into dt to integrate this. So this is now 2 by 3 into, actually this is 1 by 2. This is 1 by 3, which gives you 1 by 3. So this is now 1 by 3 sine inverse t into t square minus 1 by 3, and integration of this is t square minus 1. If I take negative out, this is 1 minus t square upon under root 1 minus t square minus, sorry, plus 1 upon under root of 1 minus t square dt. Okay, let's open up the bracket now. So this is 1 by 3 sine inverse t into t square. If I open up the bracket, this is plus now 1 by 3, and integration of 1 minus t square. So this is raised power 1, and 1 minus, so this, the root means that this is half. So 1 minus half is half. So that means this is under root 1 minus t square into dt. This becomes 1 by 3 under root 1 upon under root 1 minus t square into dt. Okay, so this is now 1 by 3 into sine inverse t into t square plus 1 by 3. And for this, we are going to use the formula under root a square minus x square. So this is the formula. We are going to use this. So which gives us half into x. So this is half into x is t. So this is t by 2 and 2 and it's plus a square by 2. So a square by 2, this is plus a square by 2, a is 1, then sine inverse x by a. So sine inverse x is t, a is 1, so t by a. This is now minus 1 by 3, and for this we are going to use a formula under root of this is 1 upon under root a square minus a x square. Okay, so this is 1 upon under root a square minus x square, which is sine inverse x by a. So this becomes sine inverse e by a, which is 1. Okay, plus c. So if we open up these brackets, so our integral is now 1 by 3 sine inverse t into t squared. This becomes 1 by 6 or t under root 1 minus t square plus this is 1 by 3 and half is 1 by 6 sine inverse t. So this is 1 by 6 sine inverse t minus 1 by 3 sine inverse t plus c. And now we are ready to make the resubstitution once again for t. So let me put in the values, or rather I can keep 1 by 3 common, which gives me sine inverse t into t square plus this is t by 2 under root 1 minus t square plus 1 by 2. Okay, 1 by 2 sine inverse t minus sine inverse t plus c. This can be simplified. Half minus 1 is negative half. So this is t square sine inverse t plus t by 2 under root 1 minus t square. This is negative half sine inverse t plus c. Okay, let's put in the value of t. So t was x raised power 3 by 2. So this is t square x raised power 3 by 2 square sine inverse x raised power 3 by 2 plus x raised power 3 by 2 under root 1 minus x raised power 3 by 2 the whole square minus half into sine inverse x raised power 3 by 2 plus c. Okay, simplifying this further gives 1 by 3, and this is now x cubed sine inverse x raised power 3 by 2 plus. The first one is x cubed sine inverse x raised power 3 by 2. This is x raised power 3 by 2 and 3 by 2 square. 1 minus x raised power 3 by 2 square gives me 1 minus x cubed. Uh, this is x raised power 3 by 2 square, which gives me 1 by x cubed minus half into sine inverse x raised power 3 by 2 plus c. This is our final answer, minus half sine inverse x raised power 3 by 2 plus c. So this is the integration. For question number 32, part A, we have to show that the function f defined from real to real number by f of x is equal to 2x upon 1 plus x square is neither 1, 1 nor odd. So this is question number 32, and this function is defined from set of real to real number. That is, domain is a real number and codomain is also the real number. And this function is defined by 2x on 1 plus x squared. Now, let's try to check its validity for 1, 1. And for that, we are going to consider two elements, x1 and x2 for domain R. And we will show that if their images are equal, then these two numbers are not the different ones, but these two are also same. For the same image, these two are also same, then the function becomes 1 and 1, which shows that for every x there is a unique y. So fx1 according to this function would be 2x1 upon 1 plus x1 squared. This is 2x2 upon 1 plus x2 the whole square. Okay, 2 and 2 gets cancelled. Let's cross multiply this, which gives me x1 plus x1 into x2 squared is equal to x2 plus x2 into x1 squared. And rearranging them gives me this is x1 x2 square negative x2 x1 square is equal to 0. So x1 minus x2, let's take negative x1 x2 out, so this becomes positive, which gives me x1 minus x2 is equal to 0. So x1 minus x2 is common. We are now left with 1 minus x1 into x2 is equal to 0. So either x1 minus x2 is equal to 0, which shows that x1 is equal to x2. So in this case, it's 1, 1, but it should also satisfy this. So this gives me that it's x1 into x2 is equal to 1. So if x1 into x2, the product of two numbers is 1, that means these two numbers are not same. That is x1 is not equal to x2. So that means function is not 1, 1. Now let's check its eligibility for onto function. And for onto function, every y should have x according to this relation. So our function is f of x is equal to 2x upon 1 plus x squared. F of x means this is y, so y is equal to 2x upon 1 plus x squared. And we have to check for every y there should be an x. So if I cross multiply this, which gives me y plus yx square is equal to 2x, and I can write it as this is x square y or yx square plus y minus 2x is equal to 0. This is a sort of quadratic equation, and we can find out the value of x. So this is minus b, that is our quadratic equation is yx square minus 2x plus y is equal to 0. Let's put this in the standard form. So this is yx square minus 2x plus y is equal to 0. Here a is equal to y, b is equal to negative 2, and c is equal to y. Okay, so x is equal to minus b plus minus root of b square minus 4ac by 2a quadratic formula, which gives me 2 plus minus root of b square, which is 4 minus 4 into y upon 2a. So this is the value of x. Now this is 4 minus 4y square by 12. Now the value of x, this is real only if this value is real. So for x to be real, under root of 4 minus 4y square should be greater than or equal to 0. So we can write for x to be real number, this 4 minus 4y square should be greater than equal to 0, because if this is negative, then we have x as imaginary numbers. So which gives me minus 4y square, and y square is greater than equal to 1, which gives me y is greater than equal to negative 1 but less than equal to 1. So this is our range. So our range is restricted to -1 to 1, and this does not belong to codomain, which was our real numbers. So that means that function is not odd. And it's also asked in the question, what should find set A so that the given function f r to a becomes an onto function. So the set A for which this function becomes onto function. So this set A, it should be for onto function, this set A should be -1 to 1. For all values for between -1 and 1, including -1 and 1, there is always a pre-image here, x. That is for every value of y in this set, there is always an x and this function becomes odd. So our answer for the last one, that for the function to become onto, for the given function to become onto a should be equal to our function should be onto a should be equal to -1 to 2. Okay. Okay, for question number 32, this is part B. And relation R is defined on n to n, where n is the set of natural numbers. So this relation is defined from n to n, and the relation is such that we have two natural numbers here and pair of two natural numbers here, and they are said to be in relation when a minus c is equal to b minus b. So when a minus c is equal to b minus b, then we say that ab is in relation with cd. Now we have to show that R is an equivalence relation. An equivalence relation is the one which is reflexive, symmetric, and transitive. So let's go for the reflexive first. First one is we will show that the, the relation is reflexive. Okay. For reflexive, let's consider an ordered pair that belongs to n. So let in comma b, it belongs to a belongs to natural number, ordered pair a, and belongs to the natural numbers. Now we have to show that it is reflexive, and the relation is reflexive when a comma b is in relation with the element itself. Okay, so we have to show this. Now let's consider, so they would be in relation when a minus a, if we are able to show that a minus a is equal to b minus b. So now a minus a will be 0 and b minus b will be 0. So which gives us that a minus a is equal to b minus b. So that means a comma b is in relation with a comma b. So the ordered pair is in relation with itself. So that means the relation is reflexive. Now let's go for the symmetric. And for symmetric, we have to reverse the relation. That is, if we are able to show that if AB is in relation with CD and CD is in relation with AB, then we say that relation is symmetric. So let AB is in relation with CD, and if AB is in relation with CD, so that means A minus C should be equal to B minus D. Let's take their negative out. So this is now negative C minus A is equal to negative D minus B. So C minus A is equal to D minus B, which means CD is in relation with AB. So that is, if AB is in relation with CD, so CD is in relation with AB, that means the relation is symmetric. So this relation is reflexive, it's symmetric, and let's go for transitive. And if we are able to prove that it's transitive as well, so that means it's an equivalence relation. So this is transitive. So this is transitive. Okay, so let's say AB is in relation with CD, and CD is in relation with, so ABCD is in relation with EF. And we have to show that AB is in relation. So this is a relation. So if we are able to show that AB is in relation with EF, and for this we have to show that A minus E is equal to B minus F. If we are able to show that, so that means they are in relation. And let's consider that these two are in relation. So this implies that A minus C is equal to B minus D. And this gives, if the relation gives C minus E is equal to D minus F. So let's add these two. So if I add 1 plus 2, which gives me A minus C plus C minus E is equal to B minus B plus D minus F. So this gets cancelled. So A minus E is equal to B minus F. So we are able to prove that A minus E is equal to B minus F. So that means AB is in relation with E. So that means R is reflexive, symmetric, and transitive. Therefore, this relation is an equivalence relation. For question number 33, we have to find the equation of the line which bisects the line segment joining the points A and B. Okay, let's say this is the required line. Now it's bisecting a line joining the points A and B. So let's say this is point A, this is point B. So point coordinates of point A are 2, 3, 4, and coordinates of point B are 4, 5, 8. And this is our required line. And let the Cartesian equation of this line be x minus x1 by A is equal to y minus y1 by B is equal to z minus z1 by C. Okay, so this, let's say this is the required equation of the line. And if I'm able to get the point through which it passes, which of course is the midpoint, because it says that it bisects the line segment joining the points. That means this line passes through point D. So now the coordinates of D is the midpoint of AB, and coordinates of D is x1 plus x2 plus x3 by 2 divided by and y coordinate is y1 plus y2, y1 plus y2 plus y3 divided by 2, and z1 plus z2 plus z3 divided by 2. Okay, x1 is 2. This is actually x1 plus x2 divided by 2, because we have the coordinates of D would be x1 plus x2 divided by 2, y1 plus y2 divided by 2, and z1 plus z2 divided by 2. Now x1 plus x2, 2 plus 4 is 6 divided by 2, y1 plus y2, 3 plus 5 is 8 divided by 2, and 8 plus 4 is 12 divided by 2, which gives me 3, 4, and 6. So the coordinates of D are 3, 4, and 6. So coordinates of D are 3, 4, and 6. Now this required line, it passes through 3, 4, and 6. So that means these are x1, y1, and z. And this equation of the line becomes x minus 3 by A is equal to y minus 4 by B is equal to z minus 6 by B. Now C. That is, we have to find the ratios, direction ratios now, which are A, B, and C. And for that, there are two more conditions that are given, that this line is perpendicular to the lines. Now, this line is perpendicular to two more lines, and the equation of these two lines are given. And the equation of the first line is x minus 8 by 3 is equal to y plus 19 by minus 16 is equal to z minus 10 by 7. Okay, and this, the equation of the second line is x minus 15 by 3 is equal to y minus 29 by 8 is equal to z minus 5 by negative 5. And these are the direction ratios A1, A2, A1, B1, C1 of this line. Let's say this is A1, B1, C1, and these are A2, B2, C2. Now, this line is perpendicular to this one, so that means the sum of the product of the direction ratios, that is A into A1 plus B into B1 plus C into C1, should be equal to 0. Now, this means that it's 3A minus 16b plus 7c is equal to 0. Also, this line is perpendicular to this one. So a into a1, so which gives me 3a, 3a plus 8b and negative 5c is equal to 0. So these are two equations, and we have to solve these equations to get the value of a, b, and c. So 3a minus 16b plus 7c and 3a plus 8b minus 5c. Okay, to get the value, because these equations have three variables a, b, and c, so that means we should have three equations, but instead of this, we have two equations. And so we will try to get the ratios of a, b, and c. So I'm going to write this as a, b, and c. Going to start with middle term, which is negative 16, then 7, then 3. In negative 16, it's 3, negative 5, 3, and 8. Okay, let's cross multiply this and subtract, multiply and subtract. So which gives me a negative 16 into negative 5 is 80 minus 8 into 7 is 56, and b is equal to 7 3s are 21 plus 15 is equal to c. This is 24 plus 16 3s are is 48. So this gives me a. This is 424 b upon 36 and c upon 72. Okay, and for this we can take 12 common. So it's a by 2, b by 3 is equal to c by 4 or 6. 12 6 are 72. So this is 8 by 2. So we can write a, let's say this is something equal to k. So this is a is equal to 2k, b is equal to 3k, and c is equal to 6k. So if we put the respective values in this equation, our required equation of line becomes x minus 3, and a was 2k, 3k, ck. So 2k, 3k, and 6k. So we can write this as y minus 4 by z minus 6 by 6 is equal to k. And finally, this equation becomes x minus 3 by 2, y minus 4 by 3 is equal to z minus 6 by 6. This is the required equation of the line. This is z. So x minus 3 by 2, y minus 4 by 3, and z minus 6 by 6 is the required equation of the line. For question number 34, part A, we have to solve the following system of equations using matrices. And this is the first, this is the second, this is the third equation. And x, y, z are not equal to 0, but these equations are in terms of the variables 1 by x, 1 by y, 1 by z. So let's form the matrices first. And This given system of matrices equations is equivalent to the matrix in the form Ax is equal to B. So our A matrix has the elements. So A is equal to 2, 3, 10, 4, negative 6, 5, 6, 9, and negative 20. And X matrix should have elements. It's not X, it's 1 by X, 1 by Y, and 1 by Z. And the B has the elements. So we should have the elements constants 4, 1, and 2. And if we have to find A, then sorry, X, then X should be A inverse of B. So that is a product of A inverse and B. And now we have to find A inverse. So A inverse is equal to adjoint of A divided by determinant of A. So let's find out the determinant of A and then the adjoint of A. So adjoint of or determinant of A, let's find out first. So determinant of A is the determinant of 2, 3, 10, 4, negative 6, 5, and 6, 9, and negative 20. And it has to be the determinant. So, okay. So let's expand it along row R1. So 2, and removing the row and the column for 2, it's the determinant is a negative 6, 5, 9, and a negative 20. Then use a negative sign for this is plus, minus, and plus. So minus 3, removing the row and the column for minus 3, it's 4, 5, 6, and negative 20 plus 10, 4, negative 6, 6, and 9. So 4, negative 6, 6, and 9. Because this is now equal to 2, negative 6 into 20 is 120 minus 45 minus 3 minus 80 minus 30 plus 10, 9 4 that is 36 and plus 36. Okay, so this gives me 2 into okay, 2 into 75 minus 3 into negative 110 plus 10 into 72. So this is 75 into 2 is 150 plus 330 plus 720. So this is 0, 2 plus 3 is 5, 5 plus 5 is 10, 7, 3, 10 plus 1, 11, and this is 1200, which is not equal to 0. That means A inverse exists. Now A inverse exists. For that, we have to find the cofactor matrix for A. So for A, let's find out the cofactor matrix. This is A1, 1. So 1 plus 1 is 2, which is even. So it's positive. And remove the row and the column for A11. Its determinant is minus 6, 5, 9, and negative 20, which gives me 120 minus 45. So this is equal to 120 minus 45. This is 75. So the first cofactor element is 75. Let's find out A12, which is negative. A131 plus 3 is positive. So removing the row and the column for A12. So A12 is this is the row and this is the column. So remove the row and the column for 3. We are left with 4, 5, 6, 4, 5, 6, and negative 20. So this is negative of negative 120 minus 30, which is equal to 150. So A12, okay, minus, sorry, this should be 4 into negative 20 is negative 80 minus 30, which is equal to 110. So this is 110. Let's find out A3. A3, remove the row and the column. So this is for A134, negative 6, 6, 9. So 9, 4, that is 36 plus 36, which is equal to 72. So I'm going to write the adjoint of A here. So adjoint of A matrix, I have got the elements. So this is 75, 110, and 72. So I will find the cofactors for this and will write them in the column form, that is 75, 110, and 72. Similarly, let's find out. So for 2, 1, 2, 2, and 2, 3. So 2 plus 1 is 3 negative. This is positive and this is negative. Removing the row and the column for 2, 1, this is 3, 10, 9, negative 20, 2, 2. It's 2, 10, 6, 2, 10, 6, negative 20. And for 2, 3, second row, and this is the second row and the third element. So 2, 3, 6, 9, 2, 3, 6, 9. So this is negative, negative 60 minus 90 is equal to 150. This is minus 40 minus 60 is equal to minus 100. This is negative 18 minus 18, which is equal to 0. So 150, negative 100 and 0. 150, negative 100 and 0. And now let's find out it for 3, 1, 3, 2, and 3, 3. So this is 3, 1, 3, 2, and 3, 3. So this is plus, this is negative, and this is plus. Removing the element in the third row and first column, we are left with 3, 10, negative 6, 5, 3, 2. So it's 3, 2, 2, 10, 4, and 5, 3, 3. 3, 3 is 2, 3, 4, and negative 6. So this is equal to 15 plus 60 is equal to 75. Negative 10 minus 40 is equal to 30. This is now negative 12. Negative 12 is equal to negative 24. 75, 30. So this is 75, 30, and negative 24. This is the adjoint of A. 75, 30, and negative 24. Okay, so let's find out A inverse now. So A inverse is adjoint of A divided by determinant of A. So adjoint of A is 1 by 1200. So it has to be divided by the value of 1200 with adjoint of A. So this is adjoint of A. And if you write down here, so this adjoint A divided by A inverse is, okay, so this is A inverse 1 by 1200. And now let's find out X. So X is equal to A inverse B. So now X is equal to A inverse B, the product of A inverse and B. So this is X, this is A inverse, and this has to be multiplied with B. And B was 4, 1, 2. So this is 4, 1, and 2. So let's multiply this. The first element would be, this would be 75 into 4 plus 150 into 1 plus 75 into 2. I'm finding out X. And second row with the column. So this is 110 into 4 minus 100 into 1 plus 30 into 2. And it's 72 into 4 plus 0 into 1 plus, this is negative 24. Negative 24 into 2. That should give me X. So x is now equal to, and it has to be divided by 1 by 200. So here it's 1 by 1200, sorry. So this is now 1 by 1200. 75 into 4 is 5, 4, 20. 7 4 are 28 and 2 is 300 plus 150 plus 150. This is 110. 440. This is 440 minus 100 plus 60. 72 into 4. 4 2s are is 8. 7 4s are is 28 plus minus 2 4s are 8 and 48. So, okay, first element is 300 plus 300 is 600. 440 plus 60 is 500 minus 100 is 400 and 288 minus 48 is 0, 4, 240. So 600, 400 and 240 has to be divided by 1200 each. So this gives me 1 by 2, 1 by 3 and 1 by, this is now 5. So this is x 240 divided by 1200. So 24, 12, 10, 2 and 1 by 5. So this is 1 by 5. Okay, so we have got x. So x is now equal to 1 by 2, 1 by 3, and 1 by 5. And this x was actually, this was 1 by x, 1 by y, and 1 by z. And equating the corresponding elements, this gives me x is equal to 2, and y is equal to 3, and z is equal to 5. So we have got the values of x2, xy, and z, x2, y3, and z5. Okay, for part B of question number 34, A matrix is given. We have to show that the transpose of A into the product of the transpose of A and A inverse is equal to this. So let's find out the transpose first, or let's find out the determinant first to check whether the A inverse exists. And to find the determinant of A, this is square matrix of order 2. So this is 1 minus 1, 1 into 1, and minus of cot x into cot x. So this is 1 plus cot square x. So determinant of A is equal to 1 plus cot square x, and we know that this is equal to cosecant square x. All right, now let's find the adjoint of A. And because this is a square matrix of order 2, so to find the adjoint of A, we will just keep these elements as it is and interchange the sign for these two. So this is cot minus cot x and this is cot x. So this is the adjoint of A for square matrix of order 2. And now we have to find A inverse. So A inverse is adjoint of A divided by determinant of A. So adjoint of A is 1 minus cot x. This is 1 and negative cot x, and this has to be divided by determinant of A, which is cosecant square x. Okay, which gives me A inverse as, so this is 1 by cosecant inverse. Okay, let's keep it as it is. Now let's find out. So this is our A inverse, and let's find out the transpose of A. So transpose of A is changing the rows into columns. So trans A is this is a matrix. So this is 1 minus cot x, change that row into column. and 1 minus cortex and cortex 1. Okay, this is the transpose of A. So A transpose we have got, and now let's get the product of A transpose and A inverse. So this is 1 minus cortex into 1. This has to be multiplied with A inverse. So this is A inverse, and this is 1 minus cortex 1, and I will just keep 1 by cosecant square x here. Okay, so A transpose into A inverse is equal to 1 by cosecant square x. Okay, this into our first column, so 1 into 1 is 1, and negative cot square x. This with the second column, so negative cot x and negative cot x. This is cot x plus cot x. This is negative cot x. So cot x, this is cot x and cot x. So this is cot x into cot is cot square x, and 1 into 1 is 1. Okay, finally we can write it as 1 upon cosecant square x, and 1 minus cot square s 2 cot x. Okay, this is now 1 minus cot square x minus 2 cot x. This is 2 cot x, and this is 1 minus cot square x, and this has to be divided by cosecant square x. So let's try to simplify this. So this is 1 minus cot square x upon cosecant square x minus 2 cot x cosecant square x, and 2 cot x upon cosecant square x. This is 1 minus cot square x upon cosecant square x. Okay, now we have this identity, or let's try to simplify this. 1 minus cot square x upon cosecant square x. So we know that cot is cos upon x, divided by cosecant is sine square x. So this is, let's take the LCM. So this is sine square x minus cos square x upon 1 by sine square x. So we are left with sine square x. So this is now equal to sine square x minus cos square x. And this, let's try to simplify this. The second term, so this one is minus 2 cot is cos by sine x. Cosecant square is 1 by sine square x. So this is now equal to 2 is equal to 2 cos x into sine x. So 2 cos x into sine x, which is equal to negative of sine 2x, because 2 cos x into sine x is sine 2x. So this is negative sine of 2x. Okay, for this one, this is cot x. Cot x is cos x by sine x. Cosecant is 1 by sine square x. This gets cancelled. So this is once again 2 cos x into sine x, and 2 cos x into sine x is sine 2x. So this is sine 2x, and we have already simplified this. So this is equal to sine square x minus cos square x. Okay, now we know that cos 2x is equal to cos square x minus sine square x. So if we take negative out of this, So this is sine square x minus cos square x, and this becomes negative cos 2x. So this is equal to negative cos 2x. This is equal to negative sine 2x. This is sine 2x, and these two are equal. So this is once again also equal to negative cos 2x. So this is now, that means the transpose of A into A inverse is equal to my negative cos 2x, negative sine 2x, sine 2x, and a negative cos 2x, and that is equal to RHS. Okay, for question number 35, it's given that A1 denotes the area of region bounded by y square is equal to 4x, x is equal to 1, and x-axis in the first quadrant. And A2 is the region bounded by y square is equal to 4x is equal to 4. We have to find the ratio of these two regions. So let's find out the area of these regions A1 and A2. And let this be our coordinate axis x, and this be y. Okay. Now y square is equal to 4x is the equation of the parabola with its axis as x-axis. So let this be the parabola y square is equal to 4x, and we will consider this parabola to be symmetric about x-axis. So this is y square is equal to 4ax, that is 4x, that is the equation of the parabola, and x is equal to 1 is a line drawn through coordinate 1 of x-axis and parallel to y-axis. So this is x is equal to 1. Okay. Now A1 denotes the area of region bounded by this parabola x is equal to 1, and x-axis, this is the x-axis, this is the parabola x is equal to 1 and x-axis, and it's given that it's in the first quadrant. So this is our region and it's A1. So let's find out the area of this region. So area of region A1 will be the integration, and limit goes from 0 to 1, and this is equal to y into dx, because we are going to consider this region as the we are going to consider this region as made up of small rectangular strips like this. Now its width is dx and its length is y. So that's why we have written y into dx. So the area of the region, I'm going to name it as OABO. So OABO. So this is the area A1, OABO, and this is made up of a small number of rectangular strips, and we are going to find the area by integrating the area of just one strip. That would be the sum total of all the area of all the strips. So y, we will get the value of y from here. So y is equal to under root 4x, which will be 2 under root x. So this is 2 under root x into dx. 2 comes out 0, and x raised power root x can be written as x raised power half dx. Now the integration of x raised power half is x raised power n plus 1, that is half plus 1 is 3 by 2, half plus 1, and it has to be validated for the limits 0 to 1. So this is 2 into 3 by 2. So okay, this would be now. So if we take the constant out, this 2 by 3, 3 by 2 becomes 2 by 3 out, and x raised power 3 by 2, 1 to 0. So this is equal to 4 by 3 into 1 raised power 3 by 2 minus 0 raised power 3 by 2, which is equal to 4 by 3 square units. So this is the area of the region A1. Now let's find out the next area and A2. Now A2 denotes the area of the region bounded by the same parabola but between x is equal to 4, and it's not confined to the first quadrant. So this is x is equal to 4. Now our concerned region between x is equal to 4, area is the area of region bounded by y is equal to 4x, x is equal to 4. So y square is equal to 4x, this is, and x is equal to 4 is our region A2, and it goes from the limits 0 to 4. So this goes from the limits 0 to 4. So our area A2 goes from 0 to 4, and it's not in the first quadrant. So I'm going to mark it as, so this is our area A2, and it's not given that it's in the first quadrant. So we will try to find out the area of this region, and because this parabola is symmetric, so we are going to find out area of this region and just multiply this region, area of this region, with 2 to get the area bounded by the parabola y square is equal to 4x and x is equal to 4. So this is equal to 2 times 0 to 4, and here we will use the same y into dx. So this is equal to 2 into limits 0 to 4, y is this is 2 root x, this is y, 2 root x, and this is now 2 into 2 is out. Integration of root x is x raised power 3 by 2 upon 3 by 2. It has to be rated for the limit 0 to 4. So this is equal to 4 into 4 by 3, and evaluated for the limits 4 raised power 3 by 2 minus 0 raised power 3 by 2. So this is now 16 by 3, and 4 square, I can write it as 2 square. So 4 square is 2 square raised power 3 by 2, which gives me 16 by 3 into 8. 2 cube is 8, so 8 6 is 48, and 128 by 3. So, okay. So we have the area of the region A2. So this is 4 into, okay, this is actually 2 by 3. So 2 into 2 is 4, and this is 2 by 3. So this is 8 by 3, and this is now 8 by 3 into 8. So which is equal to 64 by 3 square units. Now we have to find the area of the ratio of the area of these two units, that is A1 is to A2. A1 was 4 by 3 and has to be divided by 64 by 3. So this gets cancelled. 4 by 64, which is equal to 1 by 4, 1 that is 4. So 1 is to 16 is the required ratio of the regions A1 and A2. Okay, for question number 36, sorry, this is the first case study based question, and it's based on overspeeding, which increases fuel consumption and decreases fuel economy as a result of tire rolling pressure and air resistance. And vehicles reach optimal fuel economy at different speeds. Now, the fuel mileage, we know all know that usually decreases rapidly at speeds of 80 km per hour. This is the graph given for the fuel consumption at different speeds per 100 kilometer. And the relation between the fuel consumption for every 100 kilometer and speed v, that is kilometer per hour, is given by this relation f is equal to v square by 500 minus v by 4 plus 14. And on the basis of above information, we have to answer the following questions. The first one is where we have to find f when v is 40 kilometer per hour. So we are going to use this relation for the first one. So for the first one, we have to find the fuel consumption, which will be in liters for every 100 kilometers. So let's put in the value of V, which here. So V is 40. So this is 40 square by 500 minus 40 by 4 plus 40. So 40 square is 1600 divided by 500. This is 10. Negative 10 plus 14 is plus 4. Now this is equal to 16 by 5 plus 4, which is equal to 5. 16 plus 20, that is equal to 36 by 5 liter per 100 kilometer. This is the fuel consumption when the speed is 40 kilometer per hour, that is 36 by 5 liter for every 100 kilometer. Okay, and let's move on to the second part. So the first one is done. 36 by 5 liter per 100 kilometer is the fuel consumption. Hmm. For the second part, we have to find the so the second part we have to find the rate of change of fuel consumption will F is equal to V square by 500 minus V by 4 plus 14. That is, we have to differentiate this with respect to V. So differentiating this respect to V, we get is equal to V square minus, this is now 1 by 4. Differentiation of V is 1. So 1 by 4 and differentiation of 14 is 0. So this is 250. So that means df by dv is equal to 1 by 250 and v by 250 minus 1 by 4. And, and let's keep this for future reference. So this is our df. Okay. So we have got df by dv. Moving on to the third part. For okay, the third part has choices. So we are going to solve both these. So we have to find the speed v for which fuel consumption is. Okay, so for fuel consumption is minimum. Let's find out the first order differentiation which we have got. And for minimum fuel consumption, we have to find the value of v. So for minimum or maxima, so for minimum fuel consumption, our first order derivative should be equal to 0. So that means v upon 250. So v by 250 is equal to 1 by 4 and 1 by 4 into 250. 4 6 that is 24, 22.5. So the speed is 62.5 kilometer per hour. And we have to check whether at this speed fuel consumption is minimum or not. So let's find out the second order derivative. So second order derivative would be this would be 1 by 250, which is greater than 0. So that means f is minimum when speed is 62.5 kilometer per hour. So F is minimum when speed is 62.5 kilometer per hour. And let's move on to the next one. Okay, for B part of the same question, we have to find the quantity of fuel required to travel 600 kilometers at speed V. So dF by dV is given rate of change of fuel consumption with speed is given, which is negative 0.01. So we have got this dF by dV, which is V upon 250 minus 1 by 4. So this is V upon 250 minus 1 by 4 is equal to negative 0.1. I can write this as 1 by 100. So this is 250 is equal to 1 upon 100 plus 1 by 4 LCM is 100. This is 1. And this is now 4 2s are is 8 and 4 5 that is 20. So V is equal to 26 by 100 into 250. Okay, or rather, let's so 25 tens are is 250, 25 fours are is 100. This is 2 to the 4, 2 fives are and 13, which gives me y is equal. Okay, this should be this is 26 upon 100 into 250. Let me calculate it once again. So this is yeah. Now 1 by 100. This is 100, 26. Minus should be 24. So this gives me 60 kilometer per hour. So V is equal to 60 kilometer per hour. Now we have to find the quantity of fuel required to travel 600 kilometer at speed V. So speed is 60 kilometer per hour. And let's find out the quantity of fuel required. So let's use the given equation F, find out the fuel consumed at 60 kilometer per hour using this equation. So this is 60 square by 500 minus 60 upon 4 plus 40. So this is 3600 by 500 minus 60 by 4 plus 14, which gives me 36 by 5 minus this is 4 under 4, 4, this is negative 1. So this is 36 minus 5 by 5, which is equal to 31 by 5 kilometer per. So this is 31 by 5 and which is equal to 6.2. So this is 6.2 liter per 100 kilometer because this gives us per 100 kilometer consumed. So that means for 100 kilometer at this speed 60 kilometer per hour, it's 6.2 liter. And we have to find it for 600 kilometers. So for 600 kilometers, that should be 6.2 by 100 into 600, which gives me 6 to the 12, 6 6 36, 37. So that should be 37.2 liter. Okay. Moving on to question number 37. Okay, for question number 37, it's given the month of September is celebrated as the Rashtriya Poshan Ma across the country. And To follow a healthy and well-balanced diet is crucial to maintain the supply of the body with proper nutrients. And the balanced diet keeps us mentally fit and promotes improved level of energy. Though now the dietitian wishes to minimize the cost of a diet involving two types of foods, X and Y, and which are available at the rate rupees 16 per kg and 20 per kg, and the feasible region satisfying the constraints is given. And on the basis of the above information, we have to answer the following questions: identify and write all the constraints that determine the feasible region. So this is our feasible region, which is unbounded, and because it's not towards the origin, so that means the given constraints should not satisfy 0 comma 0, and that should be greater than equal to 10. First constraint. Second would be x plus y is greater than equal to 6. And so x plus 2y is greater than equal to 10. X plus y is greater than equal to 6. And the third one is 3x plus y. So this is 3x plus y. 3x plus y is greater than equal to 8. We will not consider this because this is to find the common. This was plotted to find the common region between these two planes 1 and 2. So our given constraints are this, including x is greater than equal to 0, y is greater than equal to 0. So these are the constraints for the feasible region: x plus 2y is greater than equal to 10, x plus y is greater than equal to 6, 3x plus y is greater than equal to 8, x is greater than equal to 0 for the first part. Okay, now for the second part, we have to, if the objective function is to find the minimized cost z is equal to 16x plus 2y, we have to find the values of x and y at which the cost is minimum, and also find the minimum cost, assuming that the minimum cost is possible for the given unbounded region. So let's get our corner points first. And for that, we'll find the objective z, which is 16x plus 2y. So this is 16x plus, 20y. And our corner points, the first one is this one, A. So this is 10 comma 0. Next one is B, 2 comma 4. So B is 2 comma 4. And after that, it's C, 1 comma 5. And then it's D. Okay. So let's find out the value of Z for all these coordinates. So which gives me, if I put, so this is now equal to 160 for x and y. 16 to the is 32 plus 24 is 80, which gives me 112. And this is 60 plus 20 into 5 is 100, which gives me 116. This is 0 plus 160, which is equal to 160. Okay, now it's asked in the question. So 160, 112, 116, and 160. Now the minimum cost is rupees 112. So minimum cost is rupees 110, and that is at 2 and 4. So the values at which the cost is minimum, values of x and y is x is equal to 2 and y is equal to 4, and minimum cost at these variables is 112. Okay, move on to question number 38. Okay, for question number 38, it's once again a case study based question, and it's given that airplanes are by far the safest mode of transportation when the number of transported passengers are measured against personal injuries and fatality totals. Now, the previous records state that probability of an airplane crash is 0.00001%, and there are 95% chances that there will be survivors after a plane crash. Assume that in case of no crash, all travelers survive, and E with the event that there is a plane crash, E2 with the event that there is no crash, A with the event that passengers survive after the journey, and on the base of the above information, we have to answer the following question. The first one is find the probability that the airplane will not crash. So for the first one, let's say E1 be the event. Now E1 is the event that plane crash. Now the plane crashes probability is given. This is 0.12345%. And this means that 1, 2, 3, 4, and 5 divided by 100 is the probability, which gives us two more zeros here. So it's a total of 6. So this is 1, 2, 3, 4, 5, 6, 1. So 0.00000001 is the probability that the plane will crash, but we are asked what the probability of plane will not crash, and for that the event is E2. So probability of event that plane will not crash is 1 minus probability of event that plane will crash. So 1 minus 0.123456 and 7, which gives me 0. This is 1, 2, 3, 4, 5, 6, and 7. So this is the probability that aeroplane will not crash. Okay, now for the second part, we have to find the probability of A by E1 plus probability of A by E. Now, probability of A by E1 plus probability of A by E2. Now, A is the event that passengers survive, and E1 is the event that plane is a crash. Now, when plane crashes and the passengers survive, there are 95% chances that they will be survivors after a plane crash. For this, it's 95 by 100. And for E2, the plane will not crash and there are passengers surviving, the probability is 1. So this gives me, this is 95 by 100 plus 1. So that is equal to 195 by 100 is the probability. Okay, for third one, we have to find the probability of A in for the whole scenario. So A is the event that passengers survive after the journey, so that should be equal to probability of E1 into probability of A by E1 plus probability of E2 into probability of A by E2, putting the respective values E1. So E1 was 0.000, so this is 0.12345 6 and 7 into probability of A by E1 is 95 by 100 plus probability of E2 is 0.12345 6 and 7 into probability of A by E2, which is 1. Okay, so I can write this as 1 upon, these are total of 7 decimal digits. So 1, 1, 2, 3, 4, 5, 6, and 7 into 95 by 100 plus 1, 2, 3, 4, 5, 6, and 7. So 1, 2, 3, 4, 5, 6, and 7. Okay, now our LCM would be 1, 2, 3, 4, 5, 6, 7, 8, 9, which gives me 95 plus. This is 99999 with 2 zeros, so that is equal to 99979 with 95 upon 1, 2, 3, 4, 5, 6, 7, 8, and 9. So this is the probability of A. Okay, now for the third one, we have to find the probability of E2 by A. So probability of E2 by A. So that means the passengers have survived, and we have to make sure that E2 has happened, that is there is no crash. So this is now probability of E2 into probability of A by E2. So probability of E2 into probability of A by E2 divided by probability of E1 into probability of A by E1 plus probability of E2 into probability of A by E2. Okay, this should be our required probability. Let's put in the respective values. And this E2 into A by E2. So E2 into A by E2 is this. So this is 1, 2, 3, 4, 5, 6, and 7 divided by 7, 1, 2, 3, 4, 5, 6, and 7 divided by. We have already calculated this. So it's here 2, 3, 4, 5, 6, 7, 8, and 5, and 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay, so 7 of the zeros gets cancelled. So this is now equal to 999, 999, and 900 upon 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, and 5. So this is our required property. Okay. Okay, so we have got our part B of the third one, and this finishes our the paper code 6521 subset 1. Thank you for watching.